Okay, good morning, everybody. We're going to get started on our pond turtle nesting ecology workshop. This workshop used to be called the Western Pond Turtle Nesting Ecology Workshop, but I'll explain why that has changed recently as we get started. So generally speaking, I'm going to give you lots of natural history about turtles because there's a context in which we need to understand the nesting ecology. So you're going to really kind of get a review of the entire natural history of pond turtles in California, and that will help you to understand why they nest, when they nest, how they nest, that sort of thing. This first portion is really going to be natural history, and then I'll go through little segments. You'll see a black screen with another title. I'll sort of slow down at that point, ask if there's any questions. So if you can get to those little windows where there's a black screen with a title to ask your question, that would be great. And I do really want to request that you ask questions if you have them. Now, you can ask questions in the field too, it's no problem. But if you have them about the lecture, it would be beneficial for you to ask them because I may be saying things that I think make sense, but they may not make sense to you guys because what I know about turtles is going to be very different than what you know about turtles, and I just might be missing things. So just feel free to ask questions. The other thing to keep in mind is when we're in the field, if you have field-based questions, certainly that's more than welcome. But if you have project questions, you should bring, photos or whatever imagery that you want me to see before the field date so that I have some context about answering your question, which I'm happy to do. I consider it free consulting. So feel free to bring questions about your projects to the field portion and we can go through that and answer your questions. So we're going to start off with natural history, a little bit of the boring stuff, I'm afraid. So we'll start with status, range, and ID. So just some of this will be relatively quick, just to kind of give you a review. This turtle used to be considered quite common. Around 1994, this book came out that's on the left side with a red banner around it called The Amphibian Reptile Species of Special Concern in California by Mark Jennings and Mark Hayes, and in that was the first list of species of special concern, and the turtle was in it. You can see right on the cover, the turtle's right there on the top. If we fast forward to 2016, the next version of the California Amphibian and Reptile Species of Special Concern came out, and what do you know, the turtle's right at the top again. There are reasons for that, and to some extent they were trying to connect the two documents with the imagery that they were using. But the fact that the turtle's on the cover of both editions, 1994 and 2016, does say something, and the turtle has been in really steep decline for the last 30 to 40 years. So the general status, I'll kind of do this broadly. I'll start with the Northwestern pond turtle, so the northern species. Is a California species of special concern, which we just talked about. In the state of Oregon, it's considered critical. They have a sensitive species list. It's a little different than California, but functions the same. In the state of Washington, it's considered state listed as endangered. And then many of you may know that this has been petitioned for listing at the federal level starting in 2013. That was ignored. And then as we've kind of progressed here, there was a lawsuit involved in the listing just based on the fact that the service was doing very little. And so they pushed the listing forward and decided it would likely be listed in 2016 or 17, and that kind of got ignored as well. And there's lots of dates that went in between. But the most recent information we're getting right now is the listing will likely occur in 26, but likely is in, I didn't put it in quotes, but I'm doing quote fingers here. The service is considering trying to list 3 species this year. Western spadefoot, pond turtles, both of them, and the monarch. And by trying, I'm saying they're going to try to list the monarch first, and if that all goes well, then they're going to try to list spadefoot, then the turtles. But if none of that works, and I'll just tell you it won't work, if none of that works, then they're going to wait 2.5 years and then list it first thing as a new administration comes in, if it's different than the one that we currently have. Anyway, moving on. Southwestern pond turtle. So we have two species in California, and I'll go over the map. Again, California species of special concern. Again, petition for federal listing. This one was elevated as a priority because the southwestern pond turtle is definitely in steep decline. Nevertheless, when the federal government lists both the northwestern and the southwestern, they're still both going to be threatened. Initially, they were going to be northwestern pond turtle would be threatened and southwestern pond turtle would be endangered. But there's this really complex issue with the genetics, which I'll talk about in a second or two here, that is going to create a problem for that. So they're just going to make them both threatened and solve their own problem. And then I have Baja California pond turtle in green because it's not described yet. But it is a species that they're probably going to describe. There's only 2 or 3 sites, I believe it's only 2, but I'll say there's 3 that occur in California and all the rest occur in Baja California. There's no status in Mexico currently, but these all would be lumped together and listed by the federal government either this summer or 2029. We'll have to see. So here's our turtle. This is a basking turtle. It's in the Amididae family, which really just means it's a turtle that comes out of the water to bask quite a bit, but it's also dependent upon water. So just, want to throw a photo in here to remind us what we're talking about. So here are the maps that I'm going to talk about. The original map way back in the old days, which was, I believe this was about 1870, the turtle was described as one species, and it had 2 subspecies that were not well defined. So the big red blob is western pond turtle, with northwestern pond turtle kind of in the north and southwestern pond turtle kind of in the south. And this green sort of hashed area was an intergrade zone that they didn't fully understand. So they didn't call it anything. They just said it's one of them, but they didn't define which subspecies it was. If we fast forward to today on the right side, northwestern pond turtle is everything in green. Southwestern pond turtle is everything in gold. And then there's that little blob down there with Baja California pond turtle. But it's truly only 2 or 3 sites, like 2 or 3 ponds, even though there's a big blob down there in Southern California. And that little pink box is the region where we're going to be working. So that'll be the area that we're talking about. The question about genetics came up in this area. So this hashed area now in Contra Costa, Alameda, and Santa Clara counties, but also includes San Francisco, San Mateo, Santa Cruz County, and portions of the Central Valley, is an area where we see both species. So this is not supposed to happen. If you have a species, they're supposed to be geographically isolated in some way, but it turns out that the turtle has a lot of overlap. Some of that may be from historical movement for the food trade, which would be back in like maybe the late 1800s. Nevertheless, we're stuck with lots of turtles that seem to appear to be southwestern and others that seem to appear to be northwestern in the same area. So there's a grant that was awarded to try to do a differentiation of this genetically because the service has decided, again, just to list them both as threatened to solve this problem so they wouldn't have to figure out who's in the hashed area. But the service really just drew an arbitrary line you can see on this slide that is on northern Monterey, northern San Benito, and connects to Merced County. It's a relatively arbitrary line. It really just means everything above it we don't really know. So that's how they were going to decide the 2 species, but that's not really very functional for the long term, and they were going to get sued. So now they've funded this project that should be done in the next year or so. But when we go to our site, which will be in northern Contra Costa County, we're going to see both species. We'll also see intergrades, and I'll explain how to differentiate those as best we can without genetics in just a second here. So again, that's the area we're going to be kind of focused on. Our area has some influence associated with the delta. So by that I mean there's a slough that flows into our site, and because of that, turtles that live in Napa County or Solano County or Sacramento County can go into the delta, come down to that one single slough and come into our site, and the reverse can happen. The turtles on our site can go wherever they want to as well. And quite frankly, they can go truly wherever they want to. But there are turtles in the bay that move through the bay, that go well into the delta and move into the other counties. So turtles do have the freedom to move around, and our site is one of those sites where they can definitely do that. So here's the differentiation piece. This is the only morphological characteristic that we know of that helps us differentiate between southwestern and northwestern. Now, this isn't foolproof, but it's close. So we just use it for now until they do the genetics and give us a line on a map. So we'll first look at the one on the upper slide. And what I wrote in there was the inguinal scute. That's the name of this little scale. The inguinal scute is reduced or absent. If that's the case, then it's a southwestern pond turtle. And generally speaking, I say if it looks like a grain of rice or it's not even there, then it's southwestern pond turtle. And on the lower one, the one with the big telemetry unit on it, if the inguinal scute is triangular and prominent, meaning you can see it, and I'm hoping you can see that little triangular scale there, that's northwestern pond turtle. Now, this isn't easy to remember until you look at a lot of turtles, but we're going to try to look at some turtles Thursday, Friday, or Saturday, and we'll look at this scute and see if we can differentiate between the two. So I draw these on here now just to kind of give you a better idea in case you're not seeing the imagery on the actual turtle. Excuse me. So there's a little image that looks like a grain of rice on the upper one and a little triangular shape on the lower one. That's generally the shape. They can vary quite a bit. Small turtles, it's very difficult to see, but this is sort of the broad scale version of how to differentiate these two species, especially when you're in an area where they both occur. And then I'm going to just go over the turtle sort of broadly. It's sort of a plain turtle. It's not very flashy like some of the eastern turtles. Usually about 8 inches or so would be maximum. On the site we're going to go to, the size is pretty much at the extreme end of large. So sewage treatment sites or water treatment facilities. Turtles can get much larger than is typical, but if you live in that kind of site or a warm water site, you're going to be maybe up to 8 inches or so. If you live in a river or you live in the Sierra, especially at high elevation, your average size will be smaller. But in general, you can hold this turtle with one hand. Just going back for a second here, on the left side, that's the carapace. The top of the shell is the carapace, and on the right side, the bottom of the shell is plastron. So I'll use those terms now. So here's two individual turtles, and I'm going to show you the differences in the sex, but it's not all that clear-cut all the time. So I'm going to show you already in advance that the female is on the left, the male is on the right, and I'll give you all the reasons why that's true. So the cloaca, which is the opening for waste material to leave, but also reproductive organs, is shown here where the green lines are. So what I'm trying to show you is the upper green line is touching the bottom edge of the carapace. So the shell on the top of the turtle, the edge of it is the upper line, and the cloaca is the lower line. So the cloaca is very close to the carapace or even within it, so closer to the body on a female, and on the male it's far away from the carapace, so it's extended away. And there's a reason for that, and that's as they're mating, the male turtle has to have his cloaca further from his body so it could wrap around the female's tail to have access. So the cloaca is far from the carapace for a male and not so far for a female. And then this little notch right where the tail is kind of near 90 degrees on a female, and on a male it's really wide open. And again, that's more for access, so he can move his tail around and have greater access to the female. That one is a little subtle, and you'll have to kind of pay attention to the details on that one. The plastron, so the yellow part of the shell here, is not concave on the female, so it's flattened. And on the male, it's going to be concave. There'll be a big dent where it's sort of shadowy there on the image of the male. And then moving back down to the tail. The tail on a female is short relatively speaking, and the tail on the male is long relatively speaking. The lower end of the tail is actually off the slide. So the tail is generally much longer on a male than a female. But on a site like the one we're going to go to, there are lots of otters, and otters will chew any limb off that they can. So some of them may have stubby tails, and so we use other factors instead of the tail, like the carapace, or sorry, the plastron, or the placement of the cloaca. And then one feature that works really well for older turtles is the female's face. So lower jaw, the nose area, is typically modeled, and the males has very little modeling or no modeling at all. And at the site we're going to, where there are quite old turtles, so 20, 30-year-old turtles, there's no modeling at all. If we catch some of those, then we'll definitely see that feature. And here it is kind of in profile, just to show you a female's face is very modeled, and the male's face can be very plain or bare, or without modeling. There's also another feature that I don't talk much about, but the female's nose to what is effectively her forehead is a 90 degree, and the male's slightly less than 90 degree. But the male's features are a little bit more robust in general. Their heads are bigger, their facial structure is a little longer, but you pick up these things as you go, and they're important features because often when we see a turtle, we just see a head sticking out of the water. And if you get to know these things, then you can differentiate between age and gender and species. These are age, sex, and species. So these things become important. So there it is again. And then I'll show you also on the sort of the profile version, here's a female that's on the left and a male that's on the right. The female has a more rounded carapace, so it looks more like a helmet. It's not the best angle here, but it's true. You'll see this. And the male's carapace is very flattened. And you can see overall he's sort of more compressed than she is. She has a bigger chamber in her body for holding eggs. He doesn't have that need, so his body's going to be just a little more compressed. Okay, so ID, status, and range all covered. Any questions on that? I know you'll have to unmute in order to ask your question, but it sounds like there's nobody asking
Hey,
questions.
Jeff?
Yeah. Yeah, go ahead.
Just real quickly, I'm assuming the inguinal scoot, that characteristic is also in the hybrids to be expected, like that variation of that inguinal scoot. Does that also relate to the hybrids, I guess?
Yeah, it gets really tricky, and hopefully we'll catch a couple that are hybridized. So you might find one that's triangular on the left side or the right side, doesn't matter. But on one side it'll be a big triangle, and on the other side it'll be a little grain of rice, which is telling us, okay, there's influence from both southwestern and northwestern. And some will just be sort of weird shapes, or both will be very small, but not grain of rice shaped. They'll be triangular. So we're seeing influences of, sort of past influence from the genetics of both species, and the result is kind of a mixing. It won't be clear that it's southwestern or northwestern. It will in fact be quite unclear, with some showing precisely northwestern on one side and southwestern on the other. I'm setting some traps today for us, so hopefully we'll catch a couple of those and we'll see that difference. And I'll definitely point it out and encourage you to take photos, because I find it all fascinating. So that site definitely has both species on it, and we'll see all of that.
Cool, thank you.
I also have a question, Jeff.
Yeah.
Hi. So you mentioned that the modeling is more visible or apparent on older individuals. Are we going to go over some idea of younger individuals at any point?
Yeah, I think what I was trying to say is on the older individual males, the modeling is distinctly absent. So on younger males, there'll be modeling so it'll look like a female. So we don't use the modeling as a characteristic to differentiate between male and female when they're smaller. And if we trap some smaller ones, I'll definitely point that out. But with really small ones, like meaning 7 years old or younger, there's a caveat here, and that is 7 years is approximately the age where we think they're sexually mature. So about 7 years old or younger, you can't tell male from female very easily anyways, and it's irrelevant because they're not reproductive. So if we catch those different sizes, we'll definitely talk about it. It's tricky though, as you get bigger turtles, those sexual differences come out much better. But again, when they're younger, it's truly irrelevant. They're not even reproductive members of the population, so it doesn't make a difference if they're male or female. They're just a turtle.
Okay, cool. Thanks.
But there's a lot of subtleties in this because, and I'll explain this in the field, but at our site that we're going to go to, you can get a 3-year-old turtle that is past the expected size for maturity, which is 105 millimeters. So there's an age and a size. At 105 millimeters, you should be reproductive, but we'll get a 3-year-old that's 105 because at sewage detention basins or these wastewater treatment sites, they're really nutrient rich. So turtles grow very, very fast, well beyond the typical growth rate. So we have these sort of overgrown turtles that may or may not be sexually mature. We don't even know. But a lot of that I'll talk about if we get some turtles in the hand. Okay, we'll talk a little bit about habitats here. Habitats generally are easy for turtles, but there's some complexity in it insofar as, you look at any ponded habitat and you think, yeah, that would be good for turtles. This site definitely would be. They need a little bit of upland. And by a little, I'll explain that because there's some new information on that. And they need an aquatic feature that is either wet part of the year or most of the year or all the year. And I'll go through a few of these. So ponds work great. Rivers work just great as well. So historically, this should have been called the Western creek turtle or river turtle because historically we did not have ponds in California. The ponds in California came in around 1950 to 1970. That's when most of our ponds were constructed. And reservoirs were being constructed from about 1930 to today, if you know about the site's reservoir. So we're still building reservoirs, but none of these water bodies were present as turtles were evolving. That it was all creeks and rivers. And maybe a few, like Clear Lake's a natural lake, Lake Tahoe is a natural lake, but very, very few lakes are natural in California. So typically it's going to be creeks and rivers and streams. So we have ponds, now we have creeks and rivers. Coastal creeks and rivers, and I show this photo because it's got some white water in it and turtles have no problem living in this kind of habitat. But when they do, they are typically much smaller on average. So maybe where we go, we'll see 8 or 9 inch turtle in habitats like this, and a mature adult, an old mature adult might be 6 inches. So there's a big difference because the effort it takes to live here is much greater. There's a lot of flowing water you got to fight against, and the water's cooler. So it's a little bit trickier to live here if you're a turtle, but they do just fine. And again, reservoirs are sort of prime for turtles. This is Clear Lake. So it's a natural lake, but all of the big reservoirs in California are human-made, so those end up being good habitat for turtles, even if they have non-native fishes. But turtles had to get there, so if there was a creek where they built the reservoir, then the turtles will just use the reservoir as it fills. In other cases, they're going to, like offline reservoirs, they're going to have to walk there, and occasionally they'll get dropped off by some person who doesn't want their turtle anymore. But turtles do move overland quite a bit, and they'll colonize these new places quite frequently. Again, cattle stock ponds are relatively new on the landscape, but you build a cattle stock pond anywhere near turtles' natural habitat, and they're going to use it. Agricultural ditches and drainage ditches. I live in Sacramento, so this is kind of typical for me. I see these kinds of nasty ditches that are like very, very high in nutrients and also pesticides and other things that are really eutrophic. And they're perfectly fine for turtles. Turtles don't mind low water quality, and if you haven't heard me saying it over and over, we're going to be going to a sewage treatment site, so just think about that. There are turtles in the Mojave River, in the Mojave Desert. It's a very small population that's been suffering recently because of, I don't want to say climate change, because the climate's always been really extreme in the Mojave, but let's just say decreased rainfall, decreased from 3 inches now down to 2 inches. So a big, like a 1/3 decrease in water annually, and the turtles are suffering miserably. So the little inset photo down here in the lower right is what you see if you turn around from this very spot. So pure Mojave Desert. This little piece is channelized and they can use it, but this photo was taken quite some time ago. They're no longer in this area. They're further up into the watershed. But the general point is that turtles are pretty resilient. They can use lots of different habitat types, and this is another one. Created ponds and pools. This is a project I worked on. They made this pond in the summer, and by late winter, there were already turtles in it. And this habitat turned out to be better than the natural habitat, which is the little creek in the background there. The creek was just there's too much overstory, too much shading, too cold, and they just love these ponds that got created. And I will say this over and over and over again because it turns out this is true. These wastewater treatment ponds are really prime habitat, and here's one of the big reasons. Well, there's several reasons. One is they pop up in places where there is not standing water pretty frequently. So wherever there are people, you're going to see some of these kinds of features. And turtles that might be, kind of hanging on in a pond, like in the very background near the top of this slide. Maybe the pond's kind of small and they're just hanging on there. They're going to move over to these kinds of sites where it's really nutritionally rich and do quite well. And they do well for another reason other than just the fact that it's really big and accessible. And that is the pond in the background there in the upper edge of the photo is sort of susceptible to, drought conditions and climate change and this sort of thing. The wastewater treatment ponds don't tend to have that much impact from a drought or from climate change because every time we flush our toilet, more water goes into these ponds. And I assure you, even if there's a drought, most people are flushing their toilet. Not everybody. People do it any way they want to. But somebody's going to be flushing their toilet or washing their clothes or taking a shower. And these sites just get constant water. So they're a reliable sort of resilient habitat in the face of climate change for turtles. And they will be well into the future because the more development that gets put in, the more of these get put in, and the more likely there is going to be this sort of perennial water source with a lot of nutrients. So these are sites that are getting a lot of attention recently, especially from grad students who want a reliable place to find turtles, and they don't want to go year one at a pond and year two it turns out to dry. And then their project goes away. Instead, they just use these kinds of sites, and they're really quite reliable. Ephemeral creeks and pools are important to keep in mind as well. So I'll talk about this later too in a big way because there's an important feature about all this. But all these little systems, whether they're perennial or ephemeral, function similarly for turtles. If it's a perennial system, the turtles will stay there all year and use those features. But if it's ephemeral, this dries out, the turtles just move into the upland and do what I call parking. They just push themselves into some leaf litter or duff and just wait until the creek fills up or the pond fills up, and they'll go right back to it. But one of the most important things that we're learning in the last 5 or 6 or 7 years is the uplands mean as much as the aquatic feature. Maybe if you had to split it into percentages, it would be 49-51. Uplands have, like, the importance of upland is 49% and aquatic features 51% for turtles. Turtles need and require upland areas. When I first started consulting back, yes, it's going to be a shocking to you, but in the 1980s, we gave turtles a 25-foot buffer around any aquatic feature and said that that's the habitat you need, and that's the habitat you're going to get. And in the last 40 years or so, turtles have declined, and that's partly because of that idea that we thought they didn't need very much upland, and we always find them in the water. But it turns out they need a lot of upland, and more so than we ever imagined. So that'll be a feature of discussion as we keep going here. Some of that is for nesting. Some of that is for if you get a pulse flow in a creek, they need to get out of the water and they'll move into the upland. If the creek or pond dries, they move into the upland. If they're moving between sites, they use uplands. So lots of reasons why they might use the upland. Here's a reservoir I worked on. They just constructed this over the top of a creek that flowed left to right, right through the center of the slide. And there are lots of turtles in this kind of feature, but when I look at this, I recognize turtles are going to be in the water, but much of that green area around this reservoir is turtle habitat. And by that, I really would say, sort of sweep my arm over it and say, almost everything there is turtle habitat, whether it's chaparral or grassland or barren or even urbanized. Turtles don't know what's coming when they get into the upland. They just start walking. And so all of this upland stuff is really important habitat for turtles. So here's sort of drawing down to more specific site as an example. This is a little creek, and it's got a little beaver dam right where that big plug is in the creek. And turtles, by the way, turtles love the beavers. I think they're just best friends. Beavers make the pond, the turtles use the pond. But we've even found turtles inside the beaver lodge. So beavers and turtles go together. That's just a sort of side story. But again, here's a site that I worked on. I started working on this site in the 90s. And back then, again, we were saying, well, 25 feet from the water's edge is all we need to protect. So we would do a little buffer around it and say, you could burn, plow, disc, whatever you want outside of 25 feet. But everything within the 25 feet you can't touch, because we got to protect turtles. And oh, by the way, red-legged frogs, they only got 25 feet back then too. But now what we're looking at is a need of at least 500 meters. So not in feet anymore, not 25 feet. We're talking about 1,500 feet. So essentially a quarter of a mile from any aquatic site. And so the 500 meter mark is going to cover all those needs that turtles have for uplands, which is going to be nesting, which is really critically important, movements, estivation, brumation, which is a sort of a winter estimation. All those features that we are now learning about, we think occur within about 500 meters. Now, certainly turtles are going to even exceed the 500 meters. We'll learn with time that 500 meters was not enough. And certainly if they're moving site to site, they're going to need even more. But generally speaking, when the southwestern and northwestern pond turtles get listed by the service, I've already seen their survey protocol, and it's going to include everything within 500 meters of an aquatic site. So keep that in mind. I think it's really important. Okay, anything about habitat?
Yeah, I have a quick question. Do you have an idea of how long of a hydro period you're going to need for an intermittent creek for it to be suitable?
Yeah, I do. That's actually in one of our sections that's coming up. I think it's a really important one to talk about. So I'll definitely talk about those things in detail at that time. So it's a good question, and I'll definitely get to it.
Sweet, thank you.
So yeah, go ahead.
Are you going to talk about at what point is it too steep for the turtle to get through like a barrier, upland barrier?
No, but I will. I wasn't planning to, but I definitely will. So I'll start out with the extreme. We put in little fences to block turtles from the project site we're going to go to, because we did a big restoration project at that site. So we put up all these little fences, and the fence obviously was expected to be straight up and down, and the turtles just climbed right over. They didn't have any problem at all. We see them climbing about 80 degrees without any trouble at all. If they're nesting, they'll climb anything up to around 75, 80 degrees, meaning they'll go up a slope and find some spot that they like. They won't nest on a slope like that, but they'll definitely climb it without any problem. When you look at the creek photo I showed with the beaver lodge, it had essentially 80-degree slopes, and we had turtles climbing straight up those dirt slopes. Now, occasionally they'd fall down, but they'd still climb right up. So we don't consider a rough barrier as a barrier. So by a rough barrier, I mean like piles of riprap or a fence or something like that. Now, if it's a wood fence or it's a solid surface or like Animex fencing or something like that, they can't climb it. Or they don't do very well with straight up and down surfaces like K-rail or big curbs. Even a standard curb is probably too much for most turtles. But they're going to try to get around anything. They're super persistent. So if it's a roadway and they fall into a roadway that has square curbs on each side, they'll walk until they find a sewer and then fall down the sewer. So they're gonna find a way to try to get around something. If you're putting in fencing material to try to keep turtles out, you're really going to want a solid surface fencing material. So not silt fence, they'll climb that, we've seen that. Not Urtec, they definitely climb that. They'll even climb it when it's got the little funny bend that the Urtec suggests you bend the top of the fence over. You'd be surprised what a turtle can do. It will just try to reach around and get over the bend. We've seen them doing what looks like a chin-up, so they get their front legs over the bend and they just pull their body up and over. So I would not think of a barrier to a turtle as anything that, unless it's solid surface, meaning including concrete, or wood. They don't do very well on wood. We use plywood sometimes for fencing material. And other than that, it's got to be a pit. So if you dig a deep pit, they don't seem to do very well with that. Certainly anything, that's friable if they have to climb is going to be a struggle for them. But we did an enormous restoration project on the site we're going to go to, and I'll talk a little bit about the fencing issues there and why that was a problem and what I think a barrier is.
Cool, thanks. Will they go over chain link?
There's a photo or an image or a video on YouTube with one climbing over a chain link.
Great.
Yeah, and most of the time they're going to just dig under. But they are super persistent. Okay, but briefly we're going to talk about predators. I'm going to start right here in the center on the top. We as predators are still predators, so turtles are poached in the delta in particular. So lots of turtles are being trapped and used for food. Turtles, you can eat turtles in California. It's not illegal. You just can't eat northwestern or southwestern pond turtles in California. And when somebody's catching turtles, they don't necessarily differentiate between all the species. So turtles are still in decline from being a food resource to humans. If turtles are hungry, they're very easy to trap. You can see in this trap, I think we caught 13 or 14 in one night. So if they're hungry, they're easy to trap. If they're not hungry, they're very hard to trap. And I'm going to go clockwise here. Raccoons, they'll eat little baby turtles. Otters are turtle hunters. You can see this one is crunched through a big shell. At our site that we're going to go to, if we get any turtles that have missing limbs, they're going to be due to otters. Or dead turtles, probably mostly due to otters. Otters are really pretty harsh on turtles. Coyotes, pretty rough on turtles, but mostly the babies. The babies, when they come out of the nest, stink really badly. And the nose on the front of that coyote is it's a machine for collecting baby turtles, so they're not easy on them. Fish are a bit of a question. This is, believe it or not, this is a photo of me back in the 80s holding a bass that had a red-legged frog and a turtle in it. But turtles found in the stomachs of fish are very, very rare. Fish get a lot of they're scapegoats for turtle predators, but it's very uncommon. Turtles just do not go on the list of for prey for fish very often. It doesn't mean they don't eat them. I just don't think they eat them very much. But other things, are higher on the list that we should be concerned about. And then I end with skunk on purpose. So the skunk is the primary nest raider of turtles. So tomorrow, Friday, and Saturday, we'll be looking for turtle nests. We'll be looking for nesting turtles. And if skunks have come by before us first, they will have found many of the nests and dug them up and eaten whatever contents were. And by that I mean baby turtles or eggs. These skunks will get probably 50% of the nests at any given site. This is probably the biggest predator. Now, nobody's going to say, oh, you should shoot all the skunks or trap all the skunks. It's just a normal part of life for turtles. And there are mechanisms turtles use to avoid predation on their nests, and I'll talk about that in the field. But probably the number one predator that I'm aware of, besides the next thing I'm going to show you, is skunks. It's the number one natural native predator. Here's the number one natural non-native predator, and this is way worse than the skunks. So the skunks are going to eat half the nests. Bullfrogs are going to eat 99% of the baby turtles. So if you have a site that has bullfrogs and turtles, you're less likely or not likely to see baby turtles at all. They eat them ravenously. We tell a story where we were doing bullfrog control, shooting bullfrogs. So we shot a big bullfrog, drug it out of the water, threw it on the bank, and we're going to come back around the pond a couple of times. So at the end of the night, we pick up all our bullfrogs, we open up their stomachs, see what they ate. And on the big one that we shot, there was a baby turtle in it. It was so fresh, even after sitting on the bank for 3 hours, that we knew if we had opened it up once we shot it, that little turtle would have been alive. So, here these bullfrogs are just sitting on the edge, using their enormous eyes to watch very closely. Little turtle makes a move, the bullfrog just kind of watches it, and as soon as that turtle makes the wrong move, there goes the tongue. Bullfrogs use their tongue to grab things, and then they'll jump on it and swallow the turtle down. They'll digest the whole shell, the bones, everything. This is the worst thing for turtles out there. We did bullfrog control at a site, had no baby turtles for the first 2 years, knocked down the bullfrog population by 80% in those first 2 years, and then immediately saw baby turtles. So that's not giving you all the details of the evidence, but we have direct evidence that bullfrogs are probably the worst thing for turtles. Way worse than the skunks. Skunks miss a lot of stuff. Bullfrogs don't miss much. And then, another thing, this is the barrier issue that we have to consider. So the barrier itself isn't the development. It's not, houses and fences and things. It is the roadways and then the little miniature versions of humans that live in the houses. So I'll start with the roadways. So we put in roadways, and if we have squared curbs, little turtles moving from the nest to the aquatic feature are going to be trapped on the roadway and either get run over or go down a sewer drain and then, off to the sewage treatment plant, or get shunted into a canal, then right out to the ocean. So roadways with curbs are very, very bad. The other thing is children, and I'm going to admit to being one of those children who collected a turtle when they were young. Turtles move into the uplands frequently, and I'll talk about that in detail a little bit later here. But turtles are using the uplands, and so a human will drive by or walk by, or a kid will see a turtle on the ground and think it's lost. I hear this all the time. Oh, I found a lost turtle. Let me take it to, blank, wherever that is. The creek, the river, the ocean, wherever they think the turtle needs to go. Or, into a box in the garage or wherever. And turtles don't do very well in those conditions. So the development itself takes out a lot of habitat, but still leaves habitat for nesting. Turtles can nest in this habitat, even among people's yards. But they're really going to suffer from the curbing, the sewage drains, and then the collection that comes with it. Also, random dog that's not on a leash that's going to eat a baby turtle. It's not going to help anything either. Roadways in general are not very good for turtles. It really depends on where they put the roadway, but we seem to see the roadway construction in areas that are not really well planned. I know planners put roads in, but I think that's an oxymoron. They'll put in a roadway where there's a pond on one side and the upland on the other, and they put the roadway right in between, and then the turtles have to cross back and forth, and they're just going to get run over. So roadways are a bad thing, but if you can get a roadway that's constructed with a rounded curb or no curb, then this is just an obstacle course for a turtle. They can get through it, depending on the traffic, but the curbing is the problem. And that was what Celia was talking about in terms of barriers. Barriers can be really minor, and a curb is actually a minor looking thing, but has a major impact. Then non-native competitors. So, here's a red-eared slider out of the very site that we were going to go visit. We removed all the red-eared sliders. There might be some more coming back in as we speak, but at the time we removed all the red-eared sliders because they compete for basking sites, they compete for nesting sites, and they also compete for food resources. So the bigger problem for non-native competitors is that a pond turtle will lay, on average, about 6 eggs a year. And a red-eared slider will lay 15 eggs twice a year. So they can overwhelm the native species very, very quickly. They also have this funny problem among these non-natives, and that'll be reflective in this photo. So here's a bunch of non-native red-eared sliders, and there's a western pond turtle on top of them there with his mouth open. This western pond turtle, not western, I'm going to call it a southwestern just for fun. This southwestern pond turtle is screaming in its own language to all these red-eared sliders, none of whom are listening because they don't speak that same language. So among pond turtles, this behavior is like the peak of aggression. If you're another pond turtle and you saw this male with his mouth open and his neck extended, you're going to jump off this little platform and get into the water. That's just way too intimidating. For all these red-eared sliders, they're just like, what? They don't even know what's going on. They don't care. They're not going to move. That pond turtle is just like screaming and wondering why nobody's listening. It's sort of the old man of this picture, like, God dang it, nobody's listening to me here. But they're looking, they just don't understand it. Red-eared sliders evolved with 12 other species of turtles, and they all deal with it. Pond turtles evolved with no other species of turtles. Well, occasionally, southwestern and northwestern probably intermixed. Nevertheless, they all spoke the same language, so the language coming out of this turtle might as well be nothing because nobody here is listening. That's a big problem because this pond turtle will eventually feel intimidated and get out of there. And the basking aspect for turtles is so critical to reduce pathogens on the shell, reduce fungal infections, warm them up so they can digest food, heat them up so that they can have more energy. This sort of thing is really critical. And if you're overwhelmed on your basking sites, this is really just going to be a problem. So on sites where we see lots of red-eared sliders, if the project proponent doesn't want to remove all the red-eared sliders, I just say put in hundreds of basking platforms or logs or rocks and give the pond turtles a chance. They need to bask. This isn't prime basking, obviously. My friend Kat took this photo and I both love it and hate it. That poor turtle was just miserable. Any questions about that section?
I saw several trips and I heard some chicks.
I was gonna say I didn't see him bringing anything.
You guys are having a conversation and not on mute. I'll assume that wasn't a question.
I'd like to ask if you had to categorize, so if you have a site that has bullfrog, that's a big problem, but aside with sliders, if there's enough basking platforms, then it's kind of manageable but not ideal?
It's exactly that. It's manageable, but not ideal. So here in Sacramento at the state fair, there's a big pond that we're working on, and it has about 350 red-eared sliders and 4 or 5 pond turtles. And the students from Sac State put in a whole bunch of basking material, and those pond turtles can manage because they'll always have some place to bask. But the red-eared sliders will still take the best basking. So there still is some problem and some impact. Obviously, they eat a lot of the food that's available there too. But the pond turtles can hang in there. So you would never say, well, there's 95% red-eared sliders, therefore the pond turtles are going to be, extirpated soon, so we'll give up. That's never the case. They're always hanging on, but it's just not ideal at all. And even if you took out half those red-eared sliders, it'd be good. What many of you may not know is the new survey protocol for the Fish and Wildlife Service, when the turtle gets listed, will include trapping. You'll have to trap, and you will have to, I almost said murder, but let's see, you'll have to euthanize every non-native turtle, every single one. So you'll have to have a plan for euthanizing, and it can't be freeze them or cut their head off or shoot them. It's gotta have to be American Veterinarian Association approved method, which means you pay a vet to give it an injection, and then you have to dispose of the carcass. And that could be hundreds of carcasses too, so keep all that in mind.
Wait, you're saying every protocol level survey is going to have that?
Yep.
Wow. All right.
Yeah, they have a survey protocol that's 25 pages. I think it's actually 23, but lots and lots and lots of detail, and one of the big ones is remove all non-native turtles.
Wow. All right. Great to know.
That isn't the worst thing in my mind. I think the worst thing in my mind is the public perception of you trapping turtles is not going to be very positive. The public thinks a turtle is a turtle. They don't really care. Why would they say one turtle's better than another? They're going to be mad that you're trapping turtles if anybody finds out you're killing them. So that part will be there's going to be a rough start to that, but we'll have to see when they implement all this stuff. But the protocol's already written, so it's ready to go.
I have
Okay.
a question.
Yeah.
Sorry. I have a question about red-eared sliders and nesting. Are you maybe going to talk in the field about if there's any way to differentiate between pond turtles and red-eared sliders in the field in terms of nest sites and selection?
Yeah, I definitely will if I'm prompted by seeing a red-eared slider. Generally,
Okay.
I don't talk too much about them, but because you asked, I'm happy to say if you came across an intact nest, meaning a turtle made the nest and left, and now there's eggs in the ground. If you came across an intact nest in the ground, there is 0% chance you're going to differentiate that from a red-eared slider or even a spiny softshell or a Chinese line-necked turtle, or there's 17 non-native turtles in California. You're not going to know the difference. I'm not going to know the difference. A trained dog is not going to know the difference. It's just a turtle nest. So on a project site, you would protect that, and when it hatched out, you would find out what you had, and then deal with the remains from there. If you find a nest that's predated, and that's going to be the most common thing, so you find shells on the ground, it's not easy to differentiate, but I can do it occasionally. So if you get good egg fragments that are of appropriate size and shape, I know the difference in the size and the shape of the red-eared slider, and the number. Like if I get 15 eggs, I know that's not a pond turtle. But a lot of this is guessing, so it's quite a struggle. I get lots of photos of these kinds of things, and often no scale, so I have to just take a guess, or I say I don't really know, and nobody's going to know. But it's very, very hard, and we're just talking about red-eared slider, which is actually a little easier to differentiate from one of the other, let's say about 12 of the turtles have identical eggs, identical number, nest in identical areas. You just are never going to know until they hatch. And if they hatch and they make it to the water, then you're never going to trap those babies. They're not easily trapped.
So they basically select a similar nest site, there's no kind of geographic or kind of topography difference in any of the different species.
Almost zero. The only one that's easier to detect is something like spiny softshell, which likes to nest in sand. And other turtles don't really like to nest in sand. It'll dehydrate the eggs and then they'll all perish. So if given that you have 17 non-natives to pick from and one is easy, 16 are very hard, you're sort of screwed. You just assume turtle nest, which is what we say. Oh, here's a turtle nest. But even finding a turtle nest is super rare. So I'll talk about that in the field, but it's tough. It's very, very, very tough.
Thanks.
Okay, so I'm going to talk a little bit about sympatric species. This is going to go by fast because it's not a real critical area, but the point of this is that pond turtles, southwestern and northwestern, can co-occur with other species. Obviously, I mean, they do, but often these are rare species. So in the upper left, there's giant garter snake. If we go across the top, it's San Francisco garter snake, two-striped garter snake. Down at the bottom left, red-legged frog, California tiger salamander, yellow-legged frog. Pond turtles co-occur with all of these species. They also eat all of these species. So they will just chomp onto a big chunk of snake or a big chunk of frog or a leg or a limb and eat any of these guys. The fact that some of these might be more listed, I'm saying that's sort of silly in a silly way, but more seriously listed than the turtle doesn't mean anything to the turtle. But redlegs will eat baby pond turtles. Large garter snakes can eat baby pond turtles. Giant garter snakes can eat baby pond turtles. So there can be reciprocal predation. But I've seen California tiger salamander large larva trying to get out of the pond. And I think, why is a larva trying to get out of the pond? And I went over and picked it up, and there's a turtle hanging off the back of it, definitely trying to eat it. I've seen them eating things like toads, frogs, certainly eggs of any of these things. Turtles will definitely eat anything here. The catch is, I'm pointing out that these are garter snakes. The catch is that the turtle has to eat it in water. So turtles only eat in water. And I'll say that a few more times before the day's up. So they only eat in water, therefore these garter snakes are on the list of prey. The frogs, the salamander, of course, they're all associated with water. But I'm not saying, oh, a turtle's going to eat a gopher snake, because they just don't eat on land. So you're going to have to be in water in order to be a potential prey on them. So of the rare species in California, here are things that we know turtles have eaten. So northern red-legged frog, northern leopard frog, Cascades frog, Oregon spotted frog, western spadefoot, southern long-toed salamander, California giant salamander, red-bellied newt, coast range newt. And then they co-occur with each other. These are sympatric, but they have also eaten all these ones above. They don't eat each other, but again, they're sympatric. So I'm showing that turtles co-occur with lots of rare species. When they're aquatic species, they'll eat them. If they're not aquatic, it doesn't matter. They'll still live with them. And then northwestern and southwestern, which we've talked about quite a bit, co-occur together. They just don't eat each other in this case. I'm sure there's no questions about that. It's a very brief section, but the point of that was to share that if you're managing for turtle, this is sort of the bigger picture point. If you're managing for turtle, say you're going to do a pond restoration project for turtle, and we've done this, you have to also consider that there might be other special status species there that also may need to be considered when you drain, or you throw a pile of rocks in there for basking, or you do other things. Or if you increase your number of turtles, because if you increase your number of turtles, you're increasing your level of predation on any of those special status species. So just kind of keep that in mind. Turtles and special status species all seem to go together. So reproductive, or sort of behavior in general, and then we're going to slowly shift to reproduction, because yeah, I know why we're all here. We want to talk about nesting. Again, this is a basking turtle. Here's a couple of turtles just sitting up on a tree. They climbed up on this tree, and they'll climb in the weirdest places, sometimes on the smallest twigs. But you're going to find them typically in the morning basking. They need to heat up in order to have energy to move, and they need to digest. So they need all of their organs to be warmed up. As soon as they're warm, they go into the water and they start feeding. So turtles will get out. If I had to pick a time, I would say, on a very hot day, say 8 in the morning, on a sort of an average day in the Bay Area, they would get up maybe 9 or 10, start basking for an hour or two. As soon as they're warmed up, then they'll just plunge right into the water and start foraging. Foraging can include just sitting in vegetation and eating the vegetation, just like this turtle is. Any invertebrates that are in the water are also going to be ingested. They're not very picky. They'll eat whatever's in front of them, vegetation or animal protein. It doesn't matter to them. But turtles are predators as well. So we have a site, this is not it, but we have a site where we have lots of crayfish and turtles are present, and the turtles actually keep the crayfish numbers down a little bit. So it's an important factor in crayfish control, because outside of the turtles and bullfrogs, which are super good at eating crayfish, we can't control crayfish. They're just really, really hard. But the turtles just see this as a delicacy. We know this turtle, and I know Brian Hobbs. So he tried to grab this turtle, and when he pulled it out of the water, it would not let go of that crayfish. It saw that as a really valuable item. But again, eating in water. So then here all just sort of a random smattering of things I've seen them eating, again, all in water. So even the duck that's dead, that's a carcass swimming in the water. The turtles just come underneath and start just pulling chunks off of it. A little toad, I pulled a toad out of the water that had a turtle hanging off its back leg. They just have no problem eating any of these things, listed or not. Now turtles, now I'm going to make a little bit of a shift in terms of behavior. So this is a turtle that is leaving the water. So they can leave water at night when they're already warmed up, especially on warm nights. They'll move into the uplands, and this is, for example, a female that might be trying to find a nest site. Let me skip back there. I just missed something here. I know she actually already nested. This is a turtle that I can tell already nested, because on the back side, on the bottom of the carapace near the tail, you can see a little ridge of mud. That mud means she has already dug a nest and probably buried it up again. And if you see a turtle walking through the uplands with mud on its shell, on its carapace like this, that's going to be a female that has already nested. Males never do this behavior, so that mud is a sign that she has nested. Doesn't mean successfully laid eggs, just means she dug a hole and probably buried it up. Turtles do all kinds of things to mask where their nests are, and I'll talk about that in a moment. So nesting behavior. So we're still in behavior. So a turtle will leave the water. In our area, we're going to go tomorrow, Friday and Saturday. They leave the water around 3 o'clock, 4 o'clock in the afternoon, or later. It's up to them. But they start around 3 or 4 in the afternoon. They move into the uplands very slowly, find a spot, often on the edge of grasses or some other little shrub or plant or something. And the female will urinate, then she'll dig a little, then she'll urinate and she'll dig a little, and do that over and over and over. For anything from maybe an hour to about 4 hours. That's how long it takes her to dig a hole. And then she'll drop her eggs into the hole. And then she'll start grabbing some of the dirt that she dug out of the hole and push that back in. And eventually she's going to grab this grass and push that on top of the plug of the nest. So she's covered her nest up, plugged it up with a big mud plug, and then grab grass and shove that on top of the plug. And then she'll grab more grass and loosely kind of throw it over the nest area. All of this from behind. She can't see anything that she's doing. She's doing all this blindly. And then she'll stick her head up in the air, look around, And if the coast is clear, she'll just make a mad dash for the water. Now, in some cases, she'll do this whole process but never lay any eggs at all. She'll just make a nest, plug it up, camouflage it, and then leave. And female turtles can do that multiple times, so they make these multiple phantom nests. They can do nest starts, so they dig a little and then just give up and leave because they hit a rock or a root. Lots of things they can do in these situations. We'll talk about it in the field too. If she does a good job, and I'll give you the timing of nesting and incubation a little bit later, but if she does a good job, this is what comes out of it. A little tiny turtle about the size of a quarter. Now we don't carry change anymore, but 1 inch. 1 inch is about the size of this little baby turtle that is coming out of the ground. Typically going to come out of the ground in Northern California in late February or sometime in March. If I remember, this was very late February. The turtle is very dirty, you can see, because it was living underground. And I'll explain some of that, the timing in a minute. But these little turtles will pop out of the ground and then go to the nearest patch of grass or leaf or rock or log and push their way under that for a few days, then move to the next leaf or rock or log and do that for a few days, and then make their way to water. Usually takes a week or 2 weeks to get to water, depending on how far they are from water. Okay, so I'll talk about the timing in a minute. Do you guys have any questions about what we just went through? Okay. Surely this section will give you lots of questions, so we'll make sure to give you some time to ask. So this is going to be kind of a timing of turtles and turtle behavior as a prelude to discussing nesting. So we're going to start here in kind of early spring. So early spring, turtles become active from a slow period in the winter, and they mate. Turtles are going to mate in the water. So the female's underwater, the male's breathing casually and, getting a little sun while he's doing whatever he needs to do. And they're mating in the water. It's not a behavior that's easy to see. It would just look like a single turtle is struggling. And what you don't see is the female's underwater struggling even more. It's a little like duck mating behavior. It's not all that nice. But that behavior does occur, and the male is on top of the female, holding onto the top of her shell, and his tail's wrapped around hers. And there's internal fertilization, and they're mating. And she is going to immediately start forming eggs in her body so that she's ready to lay following maybe early May. So this is early spring. They're going to be mating after they become active. And then somewhere starting around mid-May, we start seeing nesting behavior in Northern California. And by Northern California, I mean like about Fresno County north. So mating is occurring in spring. Egg laying is occurring from about mid-May to mid-July with a peak in June. That's why we do the workshop in June. So you'll see females just sort of wandering through uplands. This is a time when lots of turtles get found by people, and people think, oh, this turtle got lost, and they take it back to water, and the female has walked, like 300 yards from the water to over obstacles and around barriers and avoided predation to find a nest site, and somebody picks it up and takes it all the way back to the water. So the female is going to be walking on land to try to find a nesting spot. Along the way, she's going to drop little spots of urine. There's a reason for that, and that is when she makes a nest, her nest is going to smell like urine because as she digs, she's urinating and softening the dirt. And so that will be the smell that the skunks find. If we go back to when she leaves the pond and she starts walking toward a nest site, she's dropping little spots of urine along the way. And that's sort of a decoy to give skunks some place to dig and find nothing. And if they do it enough, skunks just don't want to waste time, so they move on. So that's sort of one of their tricks. But it also can be a big problem for the nest detection dogs that we try to use for turtles, because they'll alert to every single one of those little spots. And that may may not mean a single nest, but that's another discussion we can talk about in the field. So the females are out there this time of year making their nests. So again, she's going to kind of push into some vegetation or push up against some vegetation, usually with no or very, very little overstory. So generally not under trees, generally not in a shaded area, generally kind of in a sort of a sunnier area. All the stuff you've read in the past or heard in the past of, oh, they typically like south-facing slopes, none of that is true. They'll use any slope they want or no slope at all. South-facing slopes can be advantageous for some areas. It just depends on where it is. But generally speaking, they're going to go wherever they want to go. And if you had a map, what you find is turtles sort of nest anywhere they want to nest, not just on one slope or another. So you don't want to go down the pathway of saying, well, we're going to protect all southwestern slopes or south-facing slopes, and that's where the turtles nest, because that just isn't the way it works. And when we go to the site this week, you'll see there's no slope at all, so there's nests wherever they want to nest anyway. So here's a nesting turtle. It's got a big telemetry unit on it. This is a GPS telemetry unit on the back of this that we thought would help us find the nest. That did not help us find the nest at all. It was the red paint that helped us find the nest. So she's nesting right here. If I remove her, this is the spot that you would see after I've already moved the grass that she packed down on her nest. So finding a nest like this after they're done is essentially like winning the lottery. And I win the lottery once in a while, but not very often. But when I win, it's, $50. It's not millions. So in this case, the turtle was there. I knew it was there. I knew she was done nesting. What you're looking at is the nest plug. So she's already dug a hole. She's laid her eggs. She's pushed dirt back into that hole, smashed it all down. I'll explain this in the field, but she uses her body and actually compresses the dirt down. And she put grass on it and then camouflaged it with even more loose grass and started to walk away. We picked her up, marked her, put her back into the pond. Then I came back, and on my hands and knees, I tried to find this little wet spot and push the vegetation away to show the photo. But very, very hard to find. This was a turtle nest that they abandoned sort of mid-egg laying, so just to kind of show you what the eggs look like in the nest. So the nest hole, if you touched your index finger to the tip of your thumb, and that circle you make is about the size of the hole of a turtle nest. So it's not very big. She'll pack all her eggs in there, smash a bunch of mud on top, smash a bunch of grass on that, and then lightly throw grass on top of everything. And that's what you're going to encounter if you pulled the nest plug out. You'd see these little eggs, but we would never pull a nest plug out. But she abandoned it mid-egg laying because she saw the people who were watching her. We'll talk about that in the field too. So still sort of in the egg-laying period here. These turtles in the nest are kind of making it through the summer now, since they were laid. Most eggs are laid in June. And so the timing, I'm still going along the timing line here on the bottom. The timing is such that if you're laid in May or June, you're going to hatch in August. So it only takes about 50 days or so for them to hatch. So they're going to hatch underground, and then they're going to stay underground. That means wherever your nest was in May or in June, it's still there in September, October, November, December, but that nest is not eggs, now it's little hatchlings underground. So a hatchling turtle is a turtle that's underground. Well, once they emerge from the nest, which would be the next spring, February or March, those are post-emergent turtles. They're no longer hatchlings. So if you can imagine, they're underground in this little nest chamber in the same area that she dug initially. They've hatched out. They're kind of moving around each other. They're stepping on their eggs. Eventually they grind those little egg fragments into dust. So if you see on the ground, if you encounter a nest on the ground that has egg fragments, that's a predated nest. A hatched nest would have no egg fragments because all of its egg fragments are just dust. They'll poke their way out of the nest, and I'll show you a photo of that. But in this time frame, June, July, August, they're hatching underground, staying underground. They'll stay underground all through fall, all through winter, and in early spring, they'll emerge. So if you dug one up midwinter, this is what you would see. You'd see these little turtles in there moving around, and as they're moving, the top of their carapace is kind of wearing out the roof of their nest chamber. And so as they move around in there, they wear it out more and more and more and more, and months go by, and eventually they wear a tiny little hole in the top of the nest chamber, which is where they will eventually emerge, and I'll show you a photo of that. It's going to be a little later, so let me just continue down this pathway. So these little turtles stay in the nest, remember. The soil's damp, it's cold outside, there's, if it's a creek or stream, there's probably big pulse flows going through. That's why the turtles stay in the nest. None of this is good for a turtle. Cold weather, not good. Pulse flows, not good. Food resources are limited in the winter, so not good. So the turtles just stay in the nest, utilize their yolk. They're not using very much energy. They're just staying in there, moving around very little. And eventually, at the appropriate time, which is spring, they'll pop out, make their way to water. And remember, they got to be in water to feed. So they'll go right to water and start trying to feed on little invertebrates. So now we're at the hatchling stage. So we've made it past winter. Now we're at late February, early March, and these little hatchlings come out. So the hatchling is the one on the right. And remember, once it emerges from the nest, it's now a post-emergent turtle, or a neonate. That's an easier way. So this little neonate starts marching its way to the water. I'm going to shift you back now to the left side of the screen, where there's an active turtle, or a turtle nest there. We can see the little hole. And these little egg fragments that we found in February, but that doesn't mean they hatch. That is still a predated nest. That's just a predated nest we never found before, because we're not going to see egg fragments from a hatched nest. You're really not even going to see anything from a hatched nest. The hole is so small, you just walk right by it. All you'll know is there's little hatchlings or little neonates in the water, and you don't know where they came from. If they make it to the water. Most of them don't even make it to the water. So on my time scale down here, I have this white line that goes from June all the way through winter, and then kind of keeps going until about late February and into March. Most nests emerge in March. So a nest would be in the ground from June to March. Then these little baby turtles come out for their little walk down to the water. And when you find them, they're literally going to be about an inch. So very, very small, very hard to find, easy to miss. They'll just sit under a single leaf or a single little bit of grass, some duff, or they'll be, they'll go down a rodent hole for a short period of time. You can see on the slide or the photo on the right, there's a little sort of an umbilical scar where it was attached to the yolk. That's what it was feeding on all that time in the nest, from August when it hatched until March when it came out, which effectively is very, very little. It's just not using very much energy. But, if the female is healthy and the egg is healthy, it'll have enough energy to make it through that period. Now here's what I was talking about. Let's just say, in terms of the turtle's the neonate, it's trucked to the water. Let's start on the very right edge where there's a big red dot, and I have a little number 1, and I say, I'm just imagining this for you. On day 1, it makes it about 2 feet, and it finds a little pile of mowed lawn that it's going to push its way under. And then on day 2, it just makes a weird turn and comes under, and it sits under a little piece of curly dock. And then on day 3, it goes the other direction, and it finds a little depression in the soil next to a rodent burrow. And day 4, it goes over to another bunch of grass. Day 5, it finds another bunch of grass. Day 6, oh, it's getting closer, but it finds another bunch of grass over here. Day 7, didn't get any closer. Day 8 finally makes it into the water. This is a true section of the site we're going to go to, and that's about 30 feet wide from the right side of the screen to the left side of the screen. And to get to the water, it might take a week. In other sites where they might be 2 or 3 or 4 or 500 feet from the water, it might take them 2 or 3 weeks to get to the water. This image that you see is just after we did the restoration project. Now there's vegetation everywhere, the grass is unmowed, there's weeds everywhere. It's an enormous obstacle course for a turtle that's a half an inch tall and 1 inch wide, and many of them don't even make it to the water. They fall into a little, a footprint, or they'll get picked off by, a jay or a raven or a crow or a fox or whatever. So most of them don't make it to the water, they just die. Some of the ones that make it to the water might hit a little pile of riprap, fall between a few rocks, and be stuck. Now when you see the site, when you see it this week, there'll be cattails and bulrush everywhere. If they get to a section like that, they'll get wedged between 2 pieces of bulrush and be stuck and die. So the plight of a little tiny neonate is significant. Most of them don't make it anywhere. And by most of them, I mean 90% of them don't even make it to the water. The ones that make it to the water, now you have a whole new obstacle course to deal with. Might be non-native fish, might be bullfrogs, might be otters, might be lots of things. At this site we're going to go to, they also have mink, which regularly feed on turtles as well, baby turtles. So again, this is, a year where we had a couple of turtles come out of a nest, and we knew where the nests were, so I spent 12 years on this site just looking for turtle nests. So I've gotten a little bit, I almost said good, but that's not even close to true. I'm not even proficient. I've gotten lucky. Yeah, that's what I'll say. I've gotten lucky to find turtle nests almost exclusively by following the females. So that's what we'll do when we're out there. If we see a female leave the water, we're going to try to follow her, see where she goes, see if she makes a nest. And when you find the nest, you can put a barrier over it to protect the nest, and then watch the timing and see that these little neonates emerge. And in our case, we would collect them and move them right to the water. Okay, that's sort of nesting behavior and timing and that sort of thing. If you have any questions, I'm happy to do it. And then we can move on to nest surveys.
So it sounds like the neonate's goal is to reach the water. In that case, would nests that are positioned closer to the water, would they have a higher success rate for, at least them reaching that goal? I would think at least from nests that are, positioned farther out. I guess what's the advantage of nesting so far out when it seems like their goal is to reach the water anyway, or is it just not that they're just not thinking about that in terms of I guess more the nest being found versus the ease of the neonates reaching the water?
Yeah, I think all that's really kind of astute in a big way, and that is that turtles themselves there's a range of distance that they're going to move from water to make a nest. Some will be 5-10 feet away from the water and make a nest right there, and others will go 800 feet away and make a nest out there. And initially I used to think, well, what's the point of that? There's no way those neonates are going to make it to the pond, or if they do, they're going to be in really sad shape because they'll have burned a lot of energy and probably taken a month or so to get there. But the reality is that they didn't grow up, they didn't evolve around the kinds of ponds we have and the kinds of lakes we have. They really evolved around creeks and streams. So those have seasonal flood events that will wash out all those close nests, flood them, kill all the eggs, and those ones that nested further out will survive and maybe make it down to the water. So on the drought years where there weren't big flood events, all those close ones would be doing fine. And so there's always a population of turtles that are going to have turtles that nest far away, that have turtles that nest nearby, that have turtles that nest in sort of mid-range, and then those weirdo turtles that are going to go out, 5,000 feet and make a nest, and probably those little babies will perish, but those will be the colonizers for another site somewhere. So we do see this sort of pre-programmed idea about, like, we marked turtles at our site, for example, and we knew female 36 is a good one. She went to the same spot every year and made her nest, and she seemed comfortable going that distance. We had I don't remember the number of it, but we had another turtle that would go to the fence. There's a boundary fence on our site. It would go under the fence into the next property where the shell refinery was and nest on that site no matter what it had to do to get there. So we blocked the hole and it would find another hole. And we blocked that hole and it would dig a new hole. Because it needed, in its own brain, it needed to be far away. So we think that some individuals are pre-programmed to nest close, some are pre-programmed to nest far, with sort of the bulk of the turtles making sure they nest within, maybe a couple of 100 feet from the water. And given you have enough nests out there, some of those baby turtles will make it. But the problem is, historically, we had wetlands that were surrounded by bunch grasses, and that meant lots of open space where little neonates could make their way to the pond, and many of them did. Now we have non-native grasses that are ungrazed, unmowed, and the grass might be 4 feet tall and the thatch might be 6 inches deep, and most of them don't make it. So we have lots of challenges here. So when we're in the field, I'll talk a little bit about management of a site to promote nesting and promote access to the water. And really, it only takes a weed eater. You only need to make a couple of pathways. They'll find the path and then they'll race right to the water. But I think it's a really important question because you have to think of it sort of evolutionarily as opposed to, why is this turtle kind of being dumb? It's not really being dumb, it's being careful for the population overall. Did that help?
Yeah, and I guess I'm curious if there's like how many turtles tend to nest farther out versus closer, if there tends to be like, if it's more common one or the other, or if it just seems to be almost like a random sample.
Yeah, it depends on your site. So we'll go to a site that's very, very atypical. So it has a border fence all around its wetlands that gives about 30 to 40 feet of upland. So we know most of the turtles are nesting within that fenced area because the fence is there. But if the fence wasn't there, they would definitely be what would look like randomly distributed around our site. There's a site in Marin County that they've been looking at for about 15 years, and there's a dot for every single nest that they've ever found, and I think they have about 500 nests now, and it literally looks random. The only patches where it doesn't look random is there's a patch of trees, and they won't nest under the trees, so they sort of meander around them and go behind them, but they won't nest under the trees. So there is a way you can, given enough of this work, where you can look at a site and say, oh, I bet the turtles are going to nest here or there. But by that, I'm doing sort of arm sweeping movements because I can't say the turtles will nest in this 5 square meter area. I would be saying they'll nest in this, 10,000 square foot area over here, in this sort of big general region. But even in a year, a turtle might nest, the same turtle, like we have all our turtles marked, the turtle might nest 8 or 9 feet from water and then do a second clutch, because some of them do a second clutch, and then the second clutch might be 80 feet from water. And we don't know what triggered that, because if you're too close to the turtle when they're going to nest, they'll just run. They won't nest. Then they'll nest a completely different area. So we don't know all these triggers. I'm going to openly admit and really happily admit our learning curve is still almost straight up with nesting. The fact that I almost said stuck, but I was able to be on this site for so many years during the nesting season with the task of finding out where the turtles nested that I learned a lot, but I still feel like I feel like I'm a novice in this area, that, there's so much of my time is like still guessing and still wondering and still wanting to know more.
Thank you. It's all really interesting.
I agree, but it can be frustrating because, here I am saying, oh, we don't know very much, but you guys are coming to me to try to get answers, but, we're so early in this process that we're just doing the best we can right now, which is a lot better than we did, say, in the 90s, which was like, might as well wipe out all the turtles. So it's currently 9:35. Why don't we take a 10-minute break? We'll start again at 9:45, and I'll start right here on the nesting survey portion, which is probably one of the most important sections you guys came to this workshop for. So we'll start again at 9:45. Okay, well, we had our 10-minute break to check text and email and go to the bathroom and stuff, so we'll get going here. So we're going to talk about nesting surveys and what did and did not work for us. And by that, I'm going to just review the fact that I spent 12 years on a site just doing an effort to try to find pond turtle nests. So this project site I worked on was going to take they had 6 tertiary treated ponds, so water treatment, water came out of the industrial treatment facility and then went into ponds that were really the 3rd level of treatment, but it was already water you could swim in. But this was sort of to remove excess nitrates, and a few other things. And those ponds eventually became very eutrophic, so they had this plan to get rid of some of the vegetation and remove all the silt and kind of prolong the life of these ponds, which is what we're going to see when we go out Thursday, Friday, or Saturday. And they wanted me to figure out how to avoid killing, injuring, maiming, any turtles that might be on the site, including their nests. And because the project kept getting prolonged, sort of delayed, which is most of us know is pretty normal, they just kept adding years to my contract, and I was out there for 12 years before they finally got going on the project. In fact, I was there for 10 years, and then the project started, and we were there for a few more years. And now we just go out there to use it for the workshop. But the general point is I spent a lot of time looking for nests and doing nest surveys, and tried everything that was published and things that were unpublished, just because we felt desperate and we just wanted to try anything. So here's some of the things we did. So we trapped a really good number of pond turtles. By a good number, I think we had, our population was estimated at 127, I believe, and we trapped about 20% of those turtles, roughly about 25 turtles, had telemetry units on them. We had VHF, which is the kind you use with a little antenna, and we also had GPS, which is the one you see here. These units were fairly large, about the size of my thumb, so it took a large turtle, but we had lots of large turtles, so it worked out fine. We got a point every hour between 7 a.m. and 9 p.m. for the length of the battery life, and then that produced a map for us, and we hoped from that we could look at the points where the turtle entered the upland and spend a significant amount of time and go to that point and discover that they had nested right at that location. So here's a map of white turtle. We had different colors for all these turtles. So the white turtle did this, moved around quite a bit. We could see 2 sort of locations where it spent a lot of time over sort of in the left side there, spent a huge amount of time, but it went between 2 ponds. In fact, it actually went between 3 ponds, but only took a short trip over there. And then there's another section on the right side of the pond. The pond it spent most of its time on is Pond E, but that doesn't matter to you guys. But on the right side of Pond E, it spent a lot of time. And then on this lower half, you can see the trail on the lower half and the right, where it went into the uplands, and it spent a little bit of time doing that. And so we know from the data, it will give you the time it was there, how long it was there, at the GPS location, plus or minus 3 meters. And we went to each of these little spots and tried to figure out what was going on. So on this map, we circled the spots that we thought might potentially be a nest. So there were 6 of them that we imagined could be a nest. And we went to those spots, and remember, this is plus or minus 3 meters. So we went there and we took essentially a big grid and put it on the ground, and then we were looking around trying to find nests, and we realized very quickly we had to really get on our hands and knees and kind of push grass around and like pull apart little patches of maybe dead grass and leaves and things and try to find the nest that way. And the result was we found, with all our unmarked turtles, we found 0 nests, because the turtles mask their nest, and I shared that a little bit. So they'll put the nest plug on, pack some grass onto it, so it looks like a little patch of adobe, which looks like every other patch of dirt out there. And then they'll throw grass on top of that that's loose. So even when you're standing there looking down, the loose grass masks the nest. When you push all the grass out of the way, the packed in grass masks the nest. And what you're left with is nothing but frustration. So we spent a couple of years trying this, and we found exactly 0 nests. And I think every telemetry unit was $3,600. There's other equipment you need and some software you need. So I think they spent somewhere around $60,000 just in equipment and fees and licenses, not even counting consulting time, and we got 0. So that became very frustrating. Hard to justify continuing doing it. We managed to try it to do it a third year, but still weren't getting anywhere. So what we did was we conducted visual encounter surveys. So we really just essentially stood there or walked around and watched. And what we're doing is looking down long trails, straight trails that were mowed at the time. We had to mow the trails, and watched for turtles that left the water. And when we saw a turtle leave the water, we would sort of find some cover and use our binoculars and watch the turtle. And it might be an hour, it might be 3 or 4 hours, but we would watch the turtle during the entire process. And then what we would try to do, which turned out to be pretty tough, especially initially, is find some landmarks where the turtle was. Okay, I see that little piece of mallow, and there's some dry grass. Oh, and there's one little brown twig. That's about where the turtle is. It's between those 3 little things. The turtle starts walking back to the pond, and we would always do this in pairs, so 2 people. One would run straight for the turtle and grab the turtle and check it for marks so we would know which turtle was making the nest. The other would run straight to where we thought the nest was. And by the time you get to a site like that, what you realize is the mallow is like 3 meters away from the stick, which is 2 meters away from the other object. And now you're back to like 10 square meters, and you're looking around for these nests in that kind of mess. And so what we learned, though, was if the turtle had just finished the nest, we could get on our hands and knees and push through all that grass and find the wet spot. It was not easy, and it would usually take an hour or so. And we could find the nest. Then we would protect the nest with a little cage and secure the hatchlings and the neonates for the following year, which we could then count, when the nest emerged, the neonates emerged. And then we would have a successful nest, move those little neonates down to the water. So we did that, but really struggled initially. So we modified it slightly. So we were still walking around the water treatment facility. And what we would do then is, as we walked along, we were scanning for turtles as we were walking. And if we saw a turtle, we would drop a pin flag as close to it as we could, but on the opposite side of the trail. So at the very least, when we ran up to where the nest was, we could see that there was a pin flag directly across from it, so 90 degrees from it, and have a very small area to look for. So maybe 1 or 2 square meters, and then we could find the nest pretty easily. So in that way, we found lots of nests. On a given year, we would expect, based on the number of turtles we had, about 80 nests on this site. It's 26 acres, so about 80 nests, roughly. The skunks would find roughly on an annual basis about 40 to 45 nests. So about half of the nests were predated usually in a given year. We would find, maybe of the remaining 40-ish, following females, we would find maybe 10 nests, which would leave another 30 nests undiscovered, unknown, undetected, despite all this work. So we would work with 2 people every single day, 7 days a week from May 15th to July 15th. And we would find about 10 nests, which out of the 80 is not too good. But that's, using the same people for 10 years in a row, working every single day, 7 days a week, knowing our site and having a very, very narrow upland habitat section. So keep all that in mind as we're kind of, going through this. I'm not talking about a pond out in the middle of a grassland. We're really talking about a fenced off area with about 30 feet of upland on every side. And still, we're finding 10 out of 80 nests. Not doing too well here. So here's how it would often go. We'd see a turtle, kind of watch it for a while. She's watching us, we're watching her. We know it's a female because it's got a really domed carapace and a very mottled face. We're going to watch her walk up the slope. We're using a scope often or binoculars. We're hiding behind vegetation. She is very, very wary in this kind of time period. If there's any predator around, she's just going to abandon the idea of nesting. And instead of nesting on this side of the marsh, she might nest on the other side of the marsh the next day. So we were really careful about not spooking them. But here she is on the edge, ready to leave. It's probably 3 in the afternoon. Here we go, we're watching a turtle. So we're watching down a big pathway. I'm going to just put an arrow where the turtle is. So we're watching her walk along the pathway, and eventually she's going to find a little spot right on the edge of the road often where the grass is very short, but there's still some grass that, if you can imagine, is going to give her some kind of cover when she backs into it. She'll back into a tuft of grass, not so close that she's intersecting a bunch of roots, but close enough to kind of give her some security from behind. This is how these turtles seem to interact with the habitat out there. So we're a long way away. This is like a very, we've done the close-up on our photo here, and there's the turtle, and we're going to watch where it goes and nest. It turns out on this one, we walked up later, she left, she just did a nest start. So these are called nest starts, where she pees a little while, digs a little while, she hits too many stones, gives up, wanders off. Our 2 hours are wasted. But we had to persist. So this arrow is kind of showing the direction she was pointed. Her head is pointed in the direction of the arrow tip. And that's important because it gives us an idea of the kind of structure they're looking for to back up into. So we always marked on our photos where her head was, so we could kind of see like the look of this nest start and where her rear end was. Here's another one I came up on, just a hole in the ground. This is actually a nest start as well. This one just got a lot further, so it dug a hole in the ground. This is my actual hand. So it dug a hole in the ground. If I stick my finger in there, I could feel a big rock, and that was just too shallow for her, so she abandoned the nest. But you can see, this is the nest structure site. You can see the size of the hole is not very big. It's maybe 2 inches would be a big hole. They go straight down, and then as they go further down, they kind of open up, and then she'll have this sort of mud piled up behind her, so I know which direction she's pointed, and she's going to use that mud to pack over the top of the eggs and then smash it down with a bunch of grass. So here's that same hole without my finger in it. You can see there's a sort of a turtle shape here, and I'm going to show you where the head was. So the head is downward. She is making impressions in the mud with her legs that are these little dips on either side of the hole, on the lower end of the hole, and that helps you quickly differentiate between a rodent hole and a turtle nest hole. If this was already dry, like if she had left this for a day or so, it would be very dry, so it might look like a rodent hole. But these little dents are parts of her femur that are rubbing along the soil as she's reaching in there with her back leg to pull dirt out. So all this stuff is at the very micro level of behavior, but I find it all quite fascinating. So here's that same turtle that I had showed you earlier. If I show you where the head is, it's not all that easy on some of these. You can see where she's pointed. She's sort of tucked into some grass for some cover. If I pull the turtle off the nest, which is what we did, and then I'll show you where the nest is. The nest is right there. So this is after she's already dug her nest, after she's plugged it, after she's packed down the adobe for the plug, and then also masked it with some debris. That's the nest. So that's what you're up against with these turtles. If you're walking along, you would have zero chance of knowing there's a nest there unless you tripped and fell and your face hit some wet spot. So I pulled the grass away. That's what you see. Still, even if you see that, there's not much to see there, but there is literally a plug in the nest hole. If I had a little putty knife, I could pry that plug out and it would look like a funnel. It's got that sort of a shape, sort of an upside down triangle, and it goes all the way into and touches the tops of the eggs. So all that moisture is from her urine that she uses to pack down on that nest. What we're looking for when we're looking for nests is a nest plug, which I assure you is very, very hard. So again, she's pointed in that direction. So here is a different turtle, and I showed you this slide earlier, again showing that mud on the bottom of the carapace. So if you find a turtle walking, you know if she already made her nest or she didn't. So it's good to know this as a feature. The problem is, again, and I've said this before, you don't know if she actually made a phantom nest, so a whole nest with no eggs, or a real nest. So you just protect it anyway and hope for the best if you find it. Just pointing out where that mud is. When we find a nest, when we literally find a nest and we know it's a nest, we'll put one of these cages down on it. So it looks a little bit like a hat. So it's got a raised section in the center with a band of larger mesh screen. And that's so if we're not there at the right moment when the turtles are emerging, they could leave anyway and not be trapped in this thing. So if you trap them in there, they're all going to cook. So we do allow them to escape on their own. The apron around the edge, so this big area around the edge, is completely necessary because if you don't do that, you're going to get skunks to just dig right under it and they'll get the nest. And it takes about 18 inches of an apron to deter a skunk. Then we use these 12-inch nails with big washers to keep that edge down. Otherwise, they'll just peel this up and eat the eggs right in. I mean, you'll put this nest cage down, and the next day come back and it'll all be predated because they can get under it if you don't put every effort into it. Then we monitor this for essentially 7 or 8 months. So from June or July to February. And what we're contending with is like seasons change. So grass is going to grow through it. You got to pull this whole thing up. You got to mow down all this grass in order to see what's going on. We put some rocks on it because somebody was trying to dig under it in this case. We have a little silver tag on there with the turtle number and the date, so we know who laid right there, whose nest it was, and when it was laid. But we're constantly coming back and weed eating over this so it doesn't get stepped on or crushed because this is near or on a roadway, a dirt road, but it's like a service road. So the maintenance people don't really care about these things. They just drive right over them. But again, it allows the turtles, the neonates to leave if we're not there at the right time. So at the right time, when you approach something like this, if you do get a cage over it, and again, we're caging maybe 10 a year when there are 80 nests out there. As you get closer to, say, February, like this is late January, early February, and you look down at where your nest is, you'll see a little hole, and it's about the size of a pencil. And we call that a breathing hole, but really it's just the turtles moving in the nest so much that they're wearing the roof away, and eventually there's, some little stone or dirt clod falls out and it ends up with this little hole. Now you can put a fiber optic camera down there and see the turtles, but you can do that. It's not going to be a big disturbance, but you really want to disturb them very little at this phase because they're very sensitive to temperature, they're very sensitive to disturbance, and you want them to find their way out of this nest. When they do, all they're going to do is make a hole that's probably twice the size of that, which is maybe the size of your finger. And they're going to just start marching out of there, heading toward some sort of cover. So again, just a tiny little hole about the size of a pencil or a pen. Here they are when we have peeled this cage top off, and they're probably going to emerge the next day. So you can see them sort of pushing their way out. They're going to just poke their head out and look around for a while, and they'll make it to the next patch of, mallow or something, or doveweed or whatever it is, and just sit under a leaf and wait for the next day and move a little more and so on and so on. So this is a photo of one that we dug up in the winter, mostly because red fox had started working on it, and we just came in and chased the red fox off and got the little neonates out and moved them to water. But this, if you did dig them up, which you should not, this is what you would see. You would see some little neonates in there. Occasionally you're going to see eggs in there as well, because they don't all hatch. Sometimes you'll find nothing in there, even though she laid eggs, maybe the eggs even hatched. Gophers, believe it or not, will enter these chambers probably just opportunistically or serendipitously, and they will literally eat all these little young. So despite the fact that it's a rodent, they eat a lot of protein, and they will go in there and predate all these little nests if they can find them. And so we had a name for that. It's in one of the papers I sent you. And what you're essentially getting is this cryptic predation. So we called it cryptically predated nest. And so underground, you're waiting all those months, but the gophers have maybe already come in there and eaten everybody. And then you finally dig it up and you just have an empty hole. And it feels very frustrating. But if you kind of fish around in there, you'll find a gopher hole that probably intersected that little nest chamber. Fall works out, you get these little neonates that come out. You can move them to water if that's part of your permit. Remember, this is all got to be permitted. If you're not permitted, then you shouldn't even be handling any of these guys. But these are post-emergent turtles heading to water, haven't eaten in 7 months, just absorbing their yolk sac. When they hatch out of the egg, they actually look a little like a taco, because they're folded in the egg, but within a couple of days they flatten in the shape you see here. And they're spunky and ready to go. You can release them and they'll immediately start feeding if they find things like ostracods or copepods or those kinds of things. They'll focus on protein initially, but they'll definitely eat vegetation as well. So here's 2 or 3, I think there's 2 in this photo that we released. And they'll come out and bask in very dense cover where there's just little tiny windows of sun. Finding a neonate in the water is incredibly difficult. But what we're finding, and we've been finding this in the last year or so, is that the neonates bask at night, not in the sun, obviously, not in the moonlight, but in the warmth of surface water right on the edge. If you have big algal mats, they'll sit on the algal mat, but they'll be out at night, just sort of basking, absorbing the water temperature and being active and feeding. This is probably also why we've had so much predation by bullfrogs. That bullfrogs are out at night, mostly, and these little neonates bask at night, and if you get a package of food that size, a bullfrog's going to pick that over like a crane fly or something like that. So what we're seeing is surveying at night, you'll find neonates. Surveying the day, you might find 1 or 2 a year, but it's pretty uncommon to find these little neonates. So I'll talk about uplands if you don't have any questions about that survey aspect of things.
Jeff, I have a quick question, which is not so much about the survey, but you mentioned that sometimes the females will lay nests twice. Is that like fairly common or uncommon in a year?
Yeah, so in our turtles, since we had all of them marked and we were finding the females when they were nesting, we could say, oh, she nested in like mid-May, and now she's nesting again in late June. And that does happen. For our site, it was about 20% of the time they'll double clutch. And in the literature, it's not determined how frequent it is, but they say occasionally will double clutch. So we know that some of the early breeding females will double clutch. So it's probably more about time, like time of year that they first bred and are laying eggs, than it is about, say, size or health or anything like that. So yeah, they definitely double clutch. Some females tend to breed early, like our number 36 would always breed early, and she would always double clutch, and others as well. But we think it's about that early breeding, that if she's the first to breed, she's going to breed a second time and have another clutch. Okay, so I'll just say I'm working on a paper with Don Ashton, and what we're trying to do is create a little formula for all of us that is going to help you to determine how many turtles you would lose, given that you don't find the nest, because most of us are not going to find the nest. I see a raised hand here. Go ahead and just jump right in, Jeff.
Yeah, just following up on that last point about the double clutching. Did you see any like fidelity to the same nest site, or was it again sort of a decoy random thing?
Yeah, so what we find is that if a female likes a site, so she feels like she has success, which does not mean she, laid eggs and they all hatched out and they all made it to water. It really means she wasn't disturbed when she nested. If a female finds a nest site where she's not getting disturbed, she will go back to that kind of nest site within the same 15 or 20 square meters. So it's still a big area. But we have a site in El Dorado National Forest, the big gun mitigation site, where turtles have used the same maybe 3 square meters every year for the same 7 years in a row. Now they use lots of other sites too, but some individuals, and we don't know which ones they are because they're not marked up there, are using the same site 7 years in a row. At our site in Martinez, number 36 would use the same site. Like I could go to it tomorrow and say, oh, 36 nests right here. And if we find a nest, it was probably 36. But if we disturb her, she will stop using that site entirely and go somewhere else. And we don't know where that site is. So it can be tricky. There will be some nest site fidelity, but it's not like it's not as if you can imagine on a map, I found some turtles predated nests right here on this side of the map. Therefore, this is the turtle nesting area. There's going to be, 8 or 10 of these areas where the bulk of the turtles nest in those 8 or 10 areas. And then there's going to be random ones in other areas. And then there are going to be these outliers as well. So it can be very challenging in finding where they nest. We usually try to go out very early in May, meaning around May 15th, and see where the first early breeders are getting predated, because the early ones seem to get predated very fast. And then I at least get a picture of the habitat that they're using and start looking around for similar habitats and look for more predated nests, and then say, well, we have an idea of where some of the nesting is occurring. But never can you say all of the nests are going to be protected or all of them are going to be here or anything like that.
Yeah, sure. Yeah, that's interesting that they can modify their behavior like that.
Yeah, these are, I wouldn't call them intelligent, but I would call them adaptable. They definitely adapt to conditions in the field. So I was just going to say we're working on a paper with Don Ashton where we're looking at a formula that we could say, like if I just pick my site, the one we're going to go to this week, I can say, okay, I know the number of turtles we've trapped there. That's the new protocol we're going to trap. I know the number of turtles. I know the number of females. That'll get me to an estimated number of nests. So I think our formula will have like 1.3 times the number of nests you think are there. So that's going to account for double clutching. So 1.3 times 6.2, which is the average number of eggs, times the number of acres you have. And there's a little more detail in this, but eventually you'll get to a number of eggs that will be in that area that you may disturb. And given that number of eggs, we'll assume 100% success rate because they all may hatch. You just never know on a given year. And then you'll get a number. Like for ours, the number we calculated using our formula, and it's still just a draft, so don't panic, it was 620 some odd little neonates in a given year. We should have 620 roughly in a given year. So if we're going to do the restoration site that restoration project that we did, which means disturb the entire site, we're going to have to account for killing 600 plus turtles every year we're out there doing stuff. So now with this CDFW, there's still room to sort of negotiate that and figure out how you can manage. And in our case, we had to divide our site in half, only work on half the site so that turtles had the other half of the site, and then switch halves so that we could keep the turtles protected. On a different kind of a situation, you might have to mitigate for a lot of loss that can be calculated with the formula we're deriving from all this work we've been doing. And it's going to be tough because the service, when they list the turtle, will say, we can't give you a permit for killing 600 or 2,000 or 20 even. So how we're going to manage all that is really pretty unclear right now. But rest assured, you're not going to find all the nests. And if you're writing into your document some statement like, we will do pre-construction surveys, find all the turtle nests, we'll put a fence around them to protect them, and then when they hatch out, we'll translocate them to the water. That's really just writing something like, I know nothing about turtles, I know nothing about how to deal with it, but I'm going to put in blah, blah, blah. I mean, you could write those words instead and be the same, because you're just not going to find the nests. You'll see tomorrow and Friday and Saturday. And even if you sent somebody like me out there, I'm not saying I'm the best, I'm just saying I'm skilled, I'm not going to find most of the nests. I mean, clearly, even on my site where we know the turtles go, where we know we've been out there 7 days a week with the same people for 10 years in a row, with a 30-foot upland area, we're finding 10 nests out of 80. So pretty embarrassing, quite frankly. And on other sites, if I just sort of expand that to other sites, I'll find maybe one nest a year on average. And I think I'm pretty skilled at it. That doesn't mean anything though, because the learning curve is straight up in front of me. So it's going to be straight up in front of you guys too, I would guess. No offense, but. Okay, so moving on here. So turtles in the uplands matters because this is going to pertain to the kind of stuff I was just talking about. So to figure out what the turtles are doing in the uplands mattered because we were going to modify our uplands. We're not going to modify the water too much, although we did drain it, pull out all the silt. But the uplands are where the turtles go for refuge. If your site dries up, turtles will go into the uplands. If it gets snowy or cold or flash flooded, they'll go into the uplands. So the uplands matter a lot for turtles. So to determine how to deal with that, we conducted lots of visual encounter surveys over the course of the non-breeding portion of the year. And what we find is, like, turtles are just randomly sitting around. I know that sounds a little frustrating to hear, but these two turtles were found exactly like this at the site I walked up on them on. So I just walked in, I was like, what are these two turtles just doing here? Well, they're just sitting. They're sitting because it's in the upland, first of all. They're generally relatively protected because the river behind them is just raging. And they didn't necessarily seek or find any cover because maybe they're only going to be there a day or 2 days or a month, I don't really even know. But they're really just seeking refuge, so they're in the uplands. So if I said, well, I'm going to try to avoid disturbing turtles in the uplands by avoiding the nesting period, then I still have to contend with these adults who do this sort of upland kind of wandering. So this is the direction I'm heading here. How long are the turtles in the uplands such that you're limited on your ground disturbing activity window? So I went through all these research projects that had worked on turtles in the uplands, and I'll start with Reese up here, who did a document in 1986. And he found out that the maximum number of days his turtles were in the upland. Not the average, but the maximum was 122 days. So at least one turtle spent 122 days, which is 4 months. That's what the in parentheses number means. 4 months in the uplands. On his site, he was on the Trinity River. In the winter, the rivers are flash flow, so the turtles come out of all winter long. They're in the uplands. Holt did work in Oregon. She found that the maximum number was 115 days. She also worked on a river. Rathbun found 191. He didn't work on a river. He worked on sort of a slough that wasn't so flashy, but still found at least 6 months of the year his turtles could be in the upland. Bondi, 10 months. Bondi's turtles were in the upland 10 months of the year. Not entirely clear why they had to be in the upland 10 months of the year, because in their situation, they were working on a site that had aquatic features that were wet and suitable, but the turtles would leave anyway and not go back. Pileoid, if you want to read a really good paper about turtle behavior, especially in the uplands, Pileoid's paper talks about them being in the uplands 7 months. So they worked on stock ponds that dried down, but did not dry completely, just dried down. And as the ponds were drying down, the turtles would go into the uplands, find a log or a bunch of leaves, or go under some chaparral or whatever, and just sit there. And they waited until well after the pond filled. The pond was full for a month or more, and then they finally came back. So spent 7 months out of the water. Zaragoza had a different site in the Sierra, and what they were looking at was drying ponds, so the ponds dried completely, and the turtles had to stay out of the water a long period of time, but stayed out longer than necessary, and their maximum time was 11 months. Before I continue here, remember they don't eat unless they're in the water, so they're fasting this entire time. Purcell has the record here. So Kathleen did a study where they found the turtles stayed out for 20 months. So effectively, 2 years, your turtles are in the uplands 100% of the time. So you have to really kind of keep this in context here, because if you're doing ground disturbing activity in turtle habitat, you might have turtles in the uplands all of the time. You just don't know. And how do you find them? They're very tricky to find when they're in brumation or hibernation or estivation. All of those are different ways of saying the same thing, which is resting in the upland. And then, I throw me in here because we also have found turtles in the uplands almost a year. So I'll show you that in a timetable. But the point is to say to you, despite the fact that we have nests in the uplands, and none of this includes nesting, the adults can be in the uplands too. Breeding, not breeding, actively breeding, but nesting, nest building, nest searching, this sort of thing, estivating, brumating, hibernating, whatever it happens to be. And the average was 9 months out of the year for all these together. So it's a challenge if you're going to be doing some work around an aquatic feature that has turtles. This is more important if the federal government lists this as threatened, because we're going to have to deal with this potential loss or finding ways to survey for them, which is probably going to be raking through leaf litter and grass, flipping logs, that kind of thing, looking in burrows, that stuff. Purcell just has this crazy number I just still can barely believe. So turtles are moving into the uplands to move around, obviously, between ponds, between features. They'll just disperse as well, but they make massive movements all the time. They often, during the breeding season, they're going to be moving for breeding. And of course, these little neonates are going to be moving to the ponds. But here's the kind of thing I'm going to talk about. Here's another example of the same site we're going to visit. You might find these little red arrows are nests. Maybe those are nests, but the turtles are moving through this upland in a way that is very hard to detect. So baby turtles in particular, but big turtles too, they might be nesting in here, so they're in this sort of cover. This is actually super easy surveying because it's all mowed down or short, but in this case, at this time, it was still a little tricky because turtles moved from these nests toward the water, and they got to this gum plant And they just stayed there. They just would not move. And we found them and then moved them to the water. But the problem for them was this site gets visited by third graders as part of some education program. And they mow this all the time. So they had to mow, and we had to go out there and find all these baby turtles and move them off. And in doing so, we found adult turtles too. So there are lots of reasons why turtles in the upland might matter to you. It might be mowing, it might be grading, it might be disking, it might be development, it might be lots of things. So I'm just bringing this up because nesting in the upland is critical, obviously, but these turtles are in the upland a lot of the time. So here's kind of a quick view of it. So annually, turtle nesting will occur mid-May to mid-July. As we move forward, we see incubation of those eggs underground from June through maybe mid-September, and mid-August. And then in August, remember, they're hatching underground and they're going to stay underground. So now this darker gray band shows all those little nests are underground until maybe the end of February. So if you just look at this for nests and neonates, we have turtles in the upland from mid-May to at least the end of February. And we're not done yet. So nest emergence occurs late February into March. And then post-emergent little hatchlings are moving to water between, say, mid-March and mid-April. All of that gives you this as a window for not disturbing nesting. So neonates are not in the uplands from about mid-April to about mid-May. So if you just think about nests and nestlings and neonates, you have a disturbance window that is free of any trouble of turtles, not 100%, but let's just say 95%, in this little window between mid-April and mid-May. So there's where you can do all your ground disturbing. Don't forget you have nesting birds and other things too you have to deal with that occur in this window too. So this is essentially 11 months of the year just for nests and neonates. Now if we add in adults, so I put in this little green box here in the upper group that says, okay, here's where we're free of neonates and nests, but now we're going to put adults on the line. So adults are nesting down here in ponds. This is going to be pond habitat down here. So they're nesting at this time. If the pond dries, this is just an example. If the pond dries, they leave the pond and go into the upland to estivate. If the pond even drops in level significantly, they'll believe it's going to dry and they'll go into the upland and estivate. So you have adults from about mid-May to mid-July nesting, and now they leave and they go into the upland to estivate. If the pond is dry for the entire season, then they might go into brumation, which is a winter estivation. So they're still in the upland until almost spring. And then about February, they're going to move to the pond. This is well after ponds might be wet. So ponds might have rehydrated in December or January. And the turtles just stay in the uplands. And eventually they'll move back to the pond. And eventually by March or so, they'll start to do the breeding behavior in the water, if water is present. So now we have a window where the adults are not in the upland from about March to maybe mid-May. But remembering the neonates and the nests are still in the ground, so we still only have that little narrow window. And then if we think about the same pattern, it's very similar for creeks and rivers. Maybe the creek dries, or instead of drying, it has these pulse flows, and turtles will leave the creek or river in the same way, for the same reason. They'll go into the upland and estivate or brumate, and so you have the same sort of pattern whether you have creeks and rivers or you have ponds. The window is small, but the window is very small for nests and nestlings and neonates. So the time to do disturbance, if you don't have any breeding at all, is bigger for adults. But because you don't know if you have breeding, it's still going to be very, very narrow with those little nestlings. So you can't discard this idea of turtles absent in the uplands in March or early April, because the nestlings and neonates are still going to be there. And the problem comes from the fact that if you don't think you have breeding and you go out and you do ground disturbing blading or grading or whatever, you're going to intersect nests, which aren't very deep in the ground. They're about 3 inches below the surface, and you're going to just hit these nests, and you'll find out you had hatchlings or nestlings or neonates underground. And that's a difficult thing to report when you should know this already. If you've gone through this workshop, you're hearing me say it. You have turtles in the uplands all but 1 month a year. So if you're going to be doing ground disturbing activity, you're going to have to keep that in mind and have a permit that allows you to kill things. Here's one that we did. We did this on this very site we're going to go to. We had put in Urtec fencing, did not work because the turtles just climbed it. And we had surveyed, again, we had surveyed for nests for 10 years in a row. This section of the marsh, we thought we had never seen nesting at all. And we put up the Urtec fencing. We trapped in that area anyway, just in case there were turtles in there, moved turtles away. We were doing construction monitoring on site while they were doing grading, and they still hit a nest. They hit the nest right as the turtle was hatching, which I just, I still scratch my head when I see this photo and just think, what shitty timing we had. I mean, that was like the worst moment you could hit a turtle. It killed the turtle for sure. It's dead. I'll even show this to you when we get into the field because I have it in a little jar of alcohol. But this turtle and all its little nestling mates were all killed because the turtles made it over the Urtec fencing backwards. There's the bend only goes one way, so they made it over the fence in a different way. Got into the site, made a nest, got back over the fence, and got out of the work area, but the nest was still there and was killed. So even when you're on a site that's really well known with people who think they know what they're doing, and I use quote fingers for think, you'll still have this sort of mortality that you then have to report, and that's always a bad day. But remember that this is what we're trying to save out there. All these little nests have all these little nestlings. They're terribly cute. These are animals that are really valuable to the resource. They need a chance, and that's what we're trying to offer them. Just a chance to get to the water, to start feeding, and become a bigger turtle. If you remember what I said earlier, and I know I've given you a ton of information, but this turtle will take probably 7 years to mature, to reach a size that's going to be big enough to reproduce. And in those 7 years, they're the most vulnerable. So protecting this size is really our goal, but it is the size we know the least about. We know almost nothing about these little neonates, like how much they have to bask, how much they have to eat, all these things. They're learning stuff from populations in the Oakland Zoo, but we don't know how that translates out into the field. We only know we find lots of nests that are predated. We find lots of animals that can be digested by bullfrogs in their stomachs. But outside of that, finding a neonate is a rare event. So when you do find one, you should be excited. If you know Jeff Wilcox, he's got a ranch that has neonates every single year. You can find them very easily at night. So if you do want to find or see and photograph these little turtles, you can let me know and I can arrange to get you up there, because this is the season when they're out and they seem to be everywhere. So the resources I've used are these, and I say that mostly because I don't want you to think that I think I know everything. I used lots and lots of people's literature that they've already published. I sent around a document that has essentially a bibliography of everything published on turtles. If there's something in there that you think is important that you want, I have it as a PDF, just ask me. There's one on this list that's Nurhouse 2016. Barry did his master's on pond turtle nesting and looked at distance from aquatic sites for nesting. He's got the current record. We summarized it in a paper with my friend Colleen DeVecchio, and his work is what's contributing to the services plan to put that 500-meter length out there from aquatic features. So although the N is only 1, we are finding that the further you look, the more you find. We just never looked that far. So Barry did some really nice work on that project, and I think it's important just to point him out. The other thing I wanted to point out is there's not a lot on nesting that's been published. So I sent you a bunch of stuff that I've done, but that's most of the nesting papers. Rosenberg and Swift here in 2013 is another paper on nesting that is really well done from Oregon. They looked at nests and hatching and distance to water. It's a good paper and it's worth reading. As I sort of scan through these, all of these are important to read, but you can read too much too and then just not remember anything. But there's a lot of good resources out there, and if you need them from me, you just let me know. So I've spoken really fast, so we're actually going to get through this pretty early today. I thought we'd get through this about 12 o'clock, but it's only 10:30. So I'll definitely stop here. If you have any questions, we'll talk about those questions and answer them, and then I'll talk a little bit about the field meeting. And we're really looking at maybe another 15 to 20 minutes, depending on the number of questions. So anybody have any questions up until this point?
It's not really a question, but pretty much, Jeff, you're just saying if we're going to do any ground disturbance in like a restoration project that is around an aquatic feature with turtles, we're going to kill a bunch of babies.
I would say there's almost a guarantee you're going to kill a bunch. And if you're not killing the babies, you're just killing the eggs, and you would never even know because there's not going to be any sign of that. That'll just be a big smear on the ground. But these nests can be as close as 1 to 2 meters to the water and as far as 490, I think it's 3 or 4 meters from water. So everything in there can have nests. And typically you don't know it until you have a scraper go by and take the top 2 or 3 inches off, and then that's exactly where the nest is. 2 or 3 inches below the surface, and you're going to be you're killing them all. Because you just don't know where they are, and you're not going to know. So generally what I say to people is if you want to avoid killing a bunch of nests, you're going to have to go out there the year before your construction starts, in April, put up a fence, remove all the adults that might be getting into the fence, so that in that fenced area where you're going to have your disturbance, you've excluded turtles and nesting. And you've done that a year in advance, so there's not going to be any other nests in there. Then you have to come back in February in that same enclosure, pull out all the little neonates that have emerged that might have been in there. And that you can do by just putting in pitfalls. And then your project can proceed that April. So it would be 12 months of restricting turtles from a site and removing little neonates.
Okay.
That's not likely possible for most projects because we hear about them like, oh, they're going to start in 2 months or whatever. But this is the reality. This is turtles. So this is kind of what we're going to have to deal with, and it can be a problem because the alternative is, well, you take the formula we have, figure out how many you're going to kill based on your acreage, and then you mitigate for that, which the service doesn't allow you to mitigate for loss of animals. The department can, but the service won't. So once it's listed, it's going to be an enormous problem.
Yeah.
Yeah, I'm aware. I do this stuff too.
Thanks. Yeah.
Jeff, did you have a question? Yeah, go ahead.
Oh, I'm not Jeff.
Jeff... sorry. I saw Jeff's hand go up. One of you can go.
Okay, I'll just go. So if you have a nest that's 500 meters away from the water, obviously without considering, like you're still going to protect that habitat, but what's the actual viability of how many hatchlings can walk 500 meters to the water?
Yeah, I'm going to be honest and tell you nobody knows. But the agencies will not care the distance because they're going to say the potential is they can make it. The reality is, if you're asking me like to take an educated guess, I
Yeah.
would say, there's a less than 1% chance that even a single one will make it.
Right.
That doesn't mean that the agencies don't see it as valuable because those are the ones that are going to survive if there's some catastrophic event and there's a flood or whatever happens to be, a dam breaks or who knows what. But these turtles have evolved for any possibility, and those ones are still in the population just in case.
Yeah. Got it. Thank you.
I just had a quick follow-up on the what you were talking about, the year-long process to remove and exclude. Can you speak to any discussion about a translocation process?
Yeah, yeah. There's a couple of things in there. So I have to sort out my whole brain. So let's just talk about translocation. If you take a turtle and you move it, uh, I have to I have dyslexia, so I'm going to confuse my directions here. If you move it downstream of itself, so it's at a location, you move it downstream, it will make its way right back to where it was. It can detect the chemicals in the water and it wants to be where it was. It will go down, it will go right back upstream to wherever it was. So translocating turtles means you have to move them upstream. So all the chemistry upstream is different for them because that water and the soils and the minerals and all that is different. And so they are lost when you put them upstream and they'll stay there. So translocation can be tricky because maybe you don't even have an upstream or that's private property. But if you put them downstream, they're going to climb over any fence or walk around any barrier. Or if they can't walk around the barrier, they're going to walk out into, the grassland or into the roadway or whatever to try to get back to where they were. They are not going to be thrilled by being moved. The only way you can move them is to move them into a different watershed or a different water body or upstream to get them out of their water chemistry so that they have no idea where they are and will just stay there. We're working on a translocation project where we're going to take turtles from Petaluma and take them to Napa County. Those turtles will have no idea where to go, so they'll stay there. But if we took them from, we work on a creek called Rag Creek, and we took them from Rag Creek and put them downstream because they're going to do, a log removal at our location. They'll go right back into that work area. They will have no trouble doing that, and they will do it immediately.
Interesting. Yeah, I'm asking because I come from the construction side, but right now I'm working with mitigation banks and conservation banks. So I'm curious if if there were habitat but no turtles, if like a bank could receive translocated turtles.
They definitely could if they were from a different area. So if it's not on the same watershed, that's obviously, the downstream issue is the big one. But yeah, moving turtles to different sites, some turtles will leave anyway. So there will be a proportion that just doesn't like where they are and they're just going to leave. They aren't going to go anywhere. They'll probably just perish. They did this in Southern California near Castaic Lake, where if you go east of Castaic, there was a highly mineralized lake there that as the water drained down, all the turtles were getting caked with this mineral. And they couldn't breathe, they couldn't see, they couldn't open their mouth. So they pulled all those turtles out and they tried to move them to another site. And most of them stayed at the other site, but a few of them just left, and you're going to get that. But you have to kind of write that into your own idea for a plan, that if you move 50 turtles, maybe 30 will stay and 20 will go in some way. Go meaning get predated or leave the site or whatever. But you're not going to get 100%, but that's the case with almost everything we move. So I do think it's reasonable. You just have to move them a reasonable distance outside of their known area so that they don't detect the chemistry in the water.
Awesome, thank you.
We have projects in some areas where they're still building, they'll build a large pond inside of a creekway. And so there's a creek present, they throw some dirt in front of the creek, it backs up the water. and floods all that upland behind it, that's going to obviously flood all the nests that were associated with the creek, because if there's a creek present, they're nesting close to the creek, far from the creek, and very far from the creek. But if you back water up into that creek, it's going to flood every turtle nest in that area except the very extreme ones, which can be a benefit because at least some will survive. The adults will always just manage. The problem comes when those kinds of situations start supporting things like bullfrogs, and the bullfrogs just eat all the neonates. But lots of these projects that I work on, like I'm working on a project where we're removing non-native fish and bullfrogs from 5 ponds, and there's turtles there. So as we reduce the water level, as opposed to filling it, we're reducing it. They think the pond's drying, and they're going to move into the uplands. So you have to be prepared for turtles to move into the uplands. That's their refuge. We think of water as a refuge, but it's really the upland. If something happens, they're going to move into the upland. And so you have to kind of keep that in mind when you do construction. If you dewater a creek, the turtles are immediately going to go into the uplands if they can, not even upstream or downstream. They'll just go into the uplands. And if you're disturbing the uplands too, like you're putting in a bridge, you're going to really have to work hard to find every single turtle. And you still probably won't. So now I could hear myself answering questions I have, but I'll just move on to the field meeting unless you guys keep asking. Okay, so we're going to meet in Martinez. We should be meeting at, I believe I said 3 o'clock, and we're going to go to about 7:30. This is the Mountain View Sanitary District. We're going to, it's all locked behind a gate, so you'll go through a gate. You'll meet me at a gravel parking lot where we'll sign a liability waiver. We'll go under a freeway and then into the site itself. And once we're in there, there'll be a closed gate. But there's a bathroom and water to wash your hands, that sort of thing. This is the site itself. We're going to meet. We'll eventually get to the very lower right here where you can see a little roof, little red deck. We're going to be starting there. We'll do a little intro there. And then these ponds are the 6 ponds we'll be walking around. The red line is, most of that is a fence. So the turtles we have mostly can't get past the fence. Although when you're walking around, you'll see that there's holes under the fence. And the turtles definitely use them. So most of them, though, stay in this little series of 6 ponds. There's a slough that goes through it north to south, and that connects to the bay. So occasionally we'll get weird turtles, like we got peninsula cooter, river cooter, snapping turtle, red-eared sliders, of course, painted turtle. But they should be getting removed as we kind of progress here. That's just the nature of this project. It's under a permit that requires them to remove them when they find them. We will walk all these little trails. You can see little trails around all these ponds in couple of groups, maybe 3 groups of 3 or 4. I will be kind of walking among the groups, and I'll instruct you on how to find turtles that are nesting, turtles that are thinking of nesting. And when you see one, the idea will be you text me or yell or whatever it happens to be. Yelling is not the best idea unless I'm close by, because turtles can hear very well. And then we all gather and we watch the turtle nest, and we'll go up to the nest site and see what that looks like. We'll also just take a walk around looking for predated nests. I'll talk about nesting habitat, where the turtles typically nest, why they typically nest there. And then the sanitary district wants me to talk about their restoration project and all that, and we'll do all that too. Tonight I'll be, in fact, I'll be leaving in a few hours. I'll leave here and go out and set some turtle traps just so we can have some turtles to handle. I don't think that's ever a bad thing to do. I'll put a turtle trap in the slough that's at the very top of the photo here. I'm going to guess it's going to be empty, but we're going to trap there anyway. It'll probably have a big hole in it. And all of that is sort of a kind of a prelude to the fact that we have lots of otters on the site. So the maximum number of otters we've seen in a day is 14. They will come through the slough, usually in the evening, looking for things to eat, including turtles. If there are turtles in the trap, they'll get into the trap. They'll try to eat the turtles, but turtles are pretty good at kind of hiding their limbs. When the otters get tired, they'll rip a hole in the trap and leave. But we can catch 15 turtles in that trap if we're not disturbed by otters. So I'll still set a trap there, and then I'll set them sort of randomly other places that I know work out. This site does have, like I said, otters. It also has mink. It has coyotes, even though it's only 26 acres. Has deer on it. The shell refinery that's on the outside of it has lots of wildlife, including mountain lions, although we don't see them. They're definitely there. The shell refinery, I keep saying is shell refinery, but it is actually changed to cooking oil refinery. So used cooking oil gets trucked over to what used to be the shell refinery, and they reprocess cooking oil. So it used to be horrifying because it was shell. Now it's only bad because it's cooking oil. But expect highly industrialized looking area. This site again is very flat. There's a little bathroom there. So there's conveniences. There's some picnic benches we'll be able to eat our dinner at. I keep talking about the bugs only because when they're present, they're really bad. But when they're absent, we don't have to worry about it. The site is a little bit loud, but you shouldn't need anything like earplugs or anything like that. But we'll spend our afternoon and evening, early evening here. Hopefully we'll find some turtles that are nesting. I can't guarantee we'll find turtles that are nesting, but we will look very hard. I can't guarantee we'll find any predated nests, but I'll look around today and see if I can find any. But we'll see what is going on. But every year it's been quite reliable, and it's a really good site for turtles, so we'll see how it all goes. And then some of the turtles, well, at least one turtle still has a telemetry unit on it. So if we can catch that one, I'd love to have just popped that off. It's been a very long time for that turtle. I think that's it. Yep. So that's it for the talk. It ended about an hour early. I don't really mind myself, and I'm sure you guys will be able to get to email and other things you're working on. I'm always happy to answer questions. Just reach out to me. If you don't already remember my email address, it's jeff@thewildlifeproject.com. You can email questions. You can bring photos of your projects if you have some questions, and I'll look at them tomorrow, Friday, and Saturday. If you think you're going to have to cancel last minute for the field portion, please let me know if you can. I'm going to say my phone number here in a minute. Just text me so that we don't wait for you, because I tend to wait for people. I want everybody to get in the gate before I lock it. So I'm going to give you my phone number. Just text me if you can't make it, or if you know you're going to be late. There's signal there, so I'll get it continuously. That would just help everybody else out, so we're not just waiting for 30 minutes and nobody ever shows. So my phone number is going to be 209-815-5660. And feel free to text me questions or photos too, if that's, you want to do that. That's never a problem. But if you're going to be late or you're going to cancel, just let me know. I'd really appreciate it.
What time did you say to meet there?
3 o'clock.
All right, thank you.
Do you mind repeating your number one more time?
No, I don't mind.
Thank you.
209-815-5660.
Got it. Thank you.
And I see Jennifer is saying in the chat that I seem not to send the long list of turtle papers. I'll send that immediately. And I appreciate Laura putting in my number in the chat as well, so it's sitting there. So any other questions before we go? I'll stop the recording, which I